So we'll see all the major 5G procedures. Okay, then tomorrow we will go through various peripheral devices which come along with 5G infra lab. Each we will cover each of them, those peripheral devices in details, how to integrate with the existing 5G infra, and then in the end give the demo of their associated use cases. So that will be the major agenda of the training, which will span across 2 days. Okay. So am I at the right place? Hello.
Yes, sir.
Okay. So let me go to the next step. I assume following prerequisite to make this training more effective. Basically, I assume audience are already aware of basic understanding of wireless communication, like various building blocks, modulation and coding, etc., because that will not be covered in this course. Similarly, other basic knowledge which is assumed about various access technique being used in current cellular wireless networks. I listed few, but may not be exhaustive. Other than this wireless knowledge, some basic understanding of operating system like Linux, virtual machines, some of the microservice based environment which we are currently using like Docker. The other third dimension, which is very essential to understand this course, is various networking concepts like TCP/IP, OSI model, because these are the various protocols which is taken from this universe of the networking and then being used in this lab infrastructure. Okay, so with that, this is our typical will be the agenda for 2 days. So we have given name 1 to 20th chapters, but the title is first section deal with the introduction to 5G lab. Then section 2 is about net lab setup in terms of networks. Chapter 3 will talk about protocol deployment across all the nodes. Then in detail we go to 5G cores, then the radio access network, and chapter 6 will cover how they are integrated with each other to make them end-to-end uh, cellular calls. Then we move on to the MEC server given along with the core and network. Another section will deal with testing and tracing tool, including Wireshark. The other chapter which covers is chapter 9, end-to-end working of the working flow of this 5G lab along with its peripherals, how the various end equipment get registered and they establish sessions to achieve their effective communication. Chapter 10 will introduce some concepts of AI/ML and IoT because these two technology are very extensively integrated in our lab context. And then obviously the chapter 11 goes to make our 5G use case lab more quality intensive and at the same time taking care of the security of itself as well as the endpoint connected to it. So that's why chapter 11 cover two very important aspects. Chapter 12 cover how to manage this all component from a single point of contact, which is called NMS. Okay. Uh, then chapter 13 to 18, the focus will be to describe in detail the peripheral, which has been part of the delivery. So we'll start with various peripherals. The peripherals consist of eval board, router firewall, IoT gateway, indoor customized processor equipment, which is CPE. Then various SIM card wins supplied. So we'll discuss what is SIM card and how this can be used along with various peripherals. Obviously, the drone is a very important part of peripheral given along with this. So we'll discuss about its features, its architectures, and how this has been integrated with the 5G infrastructure part, and then see some of the its use cases. Chapter 19 will focus more uh, how these all the half a dozen peripherals they have been deployed, integrated, and this chapter will focus major demo, end-to-end use case demo. Chapter 20, although listed separately, but chapter 20 we have merged along with chapter 12, NMS. The agenda, which I in next 2 days so far, otherwise I am to first part. So these are my some navigation lab, which is covered here. Have the important and G and rack. Then we have radio unit, standalone, deployed on tripod. They are yes, devices are connected, which is a camera, which is a AR VR headset. Then we have a drone and IoT gate with various intelligent material. We have uh, it's running
Hello,
into
hello, Bhupender sir. Your voice is cracking, sir. Hello,
am I-
hello. Your voice is
yes,
cracking right now.
from okay, let me see how to
Please rejoin.
uh, let me
Hello, Ramesh ji.
Yeah, hello.
Can you make that I can present
Ducks.
here? I am sharing my screen
Yeah, yeah.
with the device. Anyone please confirm?
Your slides are visible now.
Yes.
Now, am I audible?
Hello.
Am I audible?
Bhupender ji, your voice is still cracking.
Okay.
भैया मेरे से कोई पूछेगा तो मैं बोलूंगा वॉइस की दिक्कत है इसलिए। हे श्रीकांत।
Yes.
Hello? Huh? It, if voice is clear to you.
Please allow a few minutes. We are making alternative arrangements. It will take another minute or so.
As everybody knows, part of 100 institutes to enable them uh, uh, technological capability in the next generation mobile networks within India. And with that intent, DOT and TCL has undertaken this project to set up 100 labs at various institutes. These labs provide necessary infrastructure to develop and test the 5G based applications and allow many faculty, researchers, startup to use this infra, get hands-on exercise, learn skill, and apply into various applications. So that's the purpose with which this lab is being set up at 100 institutes. Okay, so I already covered this agenda in detail. I'm moving on to now lab overview. I was describing the overall layout of the labs in terms of its various components, starting with the server rack, which house GNB, core, MEC, along with its UPS. We have a separate radio unit installed on tripod. We have various peripherals connected to it, starting the intelligent smartphone. Then we have a eval board, which allow us to do experimentations with a lot of sensors. Then we have an IoT gateway to allow the connect sensors which directly do not have 5G connectivity. Then we have camera connected to it, which is possible, so that we can do experimentation. We are set, which is connected through Wi-Fi, along with it can be connected either to CPU or any 5G enabled device in lab. And last not the least, very powerful uh, peripheral drone, which is also integrated with the 5G solutions. And with that, we can do, again, multiple kind of use case. So that's the lab layout and its overview. What comes in this 5G lab? It's a full-fledged 5G network infrastructure as a standalone 5G. Some use cases are already implemented using 5G net infrastructure. same infrastructure can be used even to extend all other future use cases. This training is from this lab to days because of this lab to 5G use case as well as forward-looking. This environment testing the 5G test. The setup will compromise obviously the various hardware components along with the within analytics. As you know, 5G is meant for uh, uh, latency, high security, uh, and all these are being as part of these solutions, and it includes customizations if required for the academia. So that's the uniqueness of the solutions because this is a totally in-house solutions. So this setup is highly customizable as per the research needs of various academic institutes. So let's see what comes to every institute. So the summary goes like this: we have a 5G core, we have a 5G radio along with the what you call RAN, which has G Node B. It comes along with V1R solution based upon IMS. We have been providing you an application server along with MEC, which have compute as well as required all the required virtualization platform and some of the applications on this hosted on this server. Also comes a network management system with detailed dashboard which help to manage all your labs various component from a single point and do extensive monitoring, configurations, and any performance monitoring as well as troubleshooting and fault rectification as you use your lab in the future. For security, we have a dedicated firewall along with the 5G infrastructure, okay, to connect various kind of devices with your lab. And the 5G SIM have been provided. I think there are around 15 numbers. So along with that, there are multiple peripherals been given so that faculty and researchers and startup can develop a variety of use case into various segments. The very first is eval board, named as eval board. This is a hardware comes with inbuilt 5G modem along with some standardized interfaces so that this board can be used as an experimental setup to develop some 5G based devices. Could be a smart home device or a smart city device application devices. So next device which is very complex and useful is gateway. So this device enable us to connect some of the sensors and devices which themselves are not capable directly interfacing to the 5G gateway. So it provides indirectly connectivity. Not only connectivity, it allow you to implement some security feature as well. So this gateway have some inbuilt firewall. Other than that, this gateway also have a capability to even remotely manage the device connected through it. Okay, so then along with this gateway, the lab also come along with I think half a dozen sensors like temperature, humidity, light, and TDS and NPK in a case of agriculture, in agriculture domain. Okay, so if we move on to the list, then we have a very powerful peripheral called drone. It's a mini drone, a very powerful and latest, you can say, capability, including autonomous navigations and onboard various sensors like cameras, and it's a very intelligent device. Then we have a CPE, which is called customer premises equipment, which enable connectivity to 5G. And other side, it provide multiple kind of interface, including Wi-Fi as well as Ethernet. So you can connect a variety of devices through this equipment to the 5G. We also have a 5G camera with associated AI-enabled video analytics, which includes face or object or motion detection. Even it can count people. So these AI-enabled analytics, along with the camera, is part of solutions which is being delivered to you. Also comes with 5G handset, which is smartphone, and associated you have a housing for your server rack, given your power supply with UPS, with battery bank. Also, we have a L2 switch to connect all your devices, come along with some testing and tracing tools. Okay, so this is the exhaustive list of deliverables which comes as a part of this 5G infra to every institute. And I hope most of institutes must have already installed, and as UAT has gone through in all the labs. So these inventory is now well known and understood by all of participants in today's workshop. This assumption is good? Can you confirm from the institute? Hello? I request please to help me get the feedback from the institute. Hello? Any professor? Any in charge? Hello?
Bhupender ji, can you repeat your question, please?
I'm asking all the institutes to confirm whether they are with me and listening to me. At least I expect some institute to in between give me some response.
Yes, this is Swagatadev Sahu, Nodal Officer from NIT Jamshedpur.
Thank you, Sarji. I expect similar kind of response so that I'm also motivated. I am talking to some institute, not
Yes,
I am
yes.
only. Yes.
My
So we
students
are
are also there. My faculty
very
members
nice.
also there. Okay.
Very nice, sir. Very nice. I want to make this session, quite interactive with you. So I'm moving now onwards. After architecture, let's go to the understand of the overall 5G network architecture. So this is a very simplistic architecture I am presenting. So here you can see there are two major subsections. One is core, which is given in a top of the picture. And in core, some of the important network function I have presented here, which in core we have AMF, which is access and management function. We have session management. Then to help in security, we have authentication servers. To store important subscriber data, we have a UDM. And then to control the various policies for subscription, we have a PCF. And then obviously to communicate with each other in service-based interface, we have an NRF. And obviously to expose to the untrusted applications, the NEF is being provided in 5G standard architecture. At the same is being retained here in our lab solutions. So in addition to core, we have the radio access network RAN, including radio. And in core network, the counterpart is UPF. And then through UPF, our UE is connected to the external data network. So this is the overall architecture of 5G network. Okay. And this 5G architecture, when this is translated into a building blocks in the lab, so they have been like this. So core, GNB and MEC has been put into the single servers, and rest of these units are separately connected through local area network connections, along with the what you call analytics software. Okay, so I think this is very simple to understand. Now let me go each and every important component which is going into the network. So I will start with the core. The core implement critical functionality like authenticating the mobile, any mobile which is connected to the core. That after proper authentication successfully, then it move on to session management. And once the session is established, various user plane processing, including ensuring service of quality maintenance, is a function of core. And the core is implemented as a containerized microservice based, and Docker is the containerized platform chosen by us. So this deployment is on server premises because solution consists of the on-premises service. It is not a cloud-based solution. And this core network architecture is mainly based on service-based architecture, which is nothing but a microservice. And again, microservice is hosted in an environment called containers managed by Dockers. And the interface among these various Docker containers is through service-based interface, which is nothing but RESTful interface, which is based upon HTTP2 protocols. And an HTTP2 protocol have multiple, methods. So those methods are being deployed for connecting the many network function on the core. Okay. So then we move to the second important building block, which is a radio access network. This radio access network, if we see, is mainly two parts. One is radio unit, which is a separately mounted. Then the rest of two entities, which is called CUDU, they are monolithic in our solutions. Together, this makes the RAN, and RAN support 2 cross 2 MIMO, and the power, because it is low power transmitter, so it only supports 100 milliwatt transmit power per antenna port, meant for indoor uses. We have CUDU functionality as per 3GPP what you call releases. DUCU is implemented on a Intel x86 architecture. This architecture is a bare metal. That means no virtualization machine. It's only on real-time Linux kernel. And then on top of that, it's containerized with the help of Docker. So this is the detail of our GNB at a very top level. And here is the some top level specification for the platform. And this is summary. Right now we'll go into detail as we move on to each and every building block. So if we talk about processor, so GNB, as I explained you, it's a Intel X based i7 platform, and the core is again from Intel, but it's a Xeon Gold 3.0, and MEC also have a similar hardware. If you talk about memory, so each and every component have 32 GB at least minimum, and storage capacity is varying from GNB to core to MEC. The highest number of storage capacity at MEC, then core, and obviously GNB does not require so much of storage, henceforth it is provided as per the requirement of the component. If you talk about the other details, like very important part after hardware comes BIOS, which enable important optimization of the hardware underlying. So corresponding, you can see the GNB is a very specialized hardware to take care of the very, very intensive compute need of radio network. So it has been highly optimized with the help of BIOS setting as well. So it support hyperthreading. It also enable various virtualization at hardware level, which is called SRBIO. Then we have various profiles programmed here. And for core and MEC, these are default BIOS setting, not customized. For operating system concern, all the three, if you see, we have Ubuntu 2204, the latest, right? And the kernel in all the three, the kernel, which is a subset of operating system, but which is the engine behind the real-time response, is kernel. And that's the real-time kernel across all the three nodes in the lab. If you go beyond kernel and OS, then we have all the three nodes supports, virtualization or microservice-based architecture, which is a direction to go in future. So version of Docker is 26, which is most stable and recent version. And along with Docker come Docker Compose, which basically manage this container-based environment, provide orchestration services, which is a very close extension of the Docker itself. Docker is the engine, and this is a call management platform. So if you go version, that is also stable, and the latest version is being deployed at your institute's lab. Other component which is to be noticed is GNB, which is, I mentioned already, it is very compute intensive or real-time demanding. So another utility in Linux, which is PTP, which is used to synchronize the hardware clock in this. So this is this Linux utility is being again utilized in our solutions. So if we go to now to the network configurations which have been deployed at your institutes, various institutes. So server IP will be like for GNB, X will vary from institute to institute. Otherwise, remaining portion of the IP address will remain same for across all the institutes. So server IP, then we have a net mask, and the gateway is only X will vary. And you can say net mask is across all institutes the same. IP forwarding is enabled in all the solutions, and some of the routes which been provided at various institutes are listed in IP route configurations. So these are the details. So let's go to now the third aspects of the network. So, in any modern cellular network, protocols play a very important role. So, as you know, protocols are nothing but a very standardized way of communicating between various entities. The same goes here in 5G lab. So, various kind of protocols being deployed in our solutions. So, we can understand this overall protocol deployment with the help of two major schemes. One is called reference point based architecture, where every network function talk to next application with the help of a very customized interface. So that's why they call reference based architecture. The alternate, which is more neat and clean and less complex, which is being used by us in our solution, is called service based architecture. So that is being used. So here are two major category of protocols. One is called user plane, where focus is end-to-end from UE to your external server. What are the various protocol is being deployed? So this current slide very nicely capture at the very top level without going into the bit and byte, but this explains how UE communicate to GNV using various layers. So that's why I was mentioning my pre-decree. This is nothing but very similar layers like any TCP and OSI layer. We start with the physical layer, which deals how to transmit electrical signal at the hardware level. Then the next layer comes the MAC, which is called media access control, which is basically at very simple level. If I say it manage the hardware resource effectively in terms of saddling, which channel at what time in which direction to give. That's the major job of MAC layer. Then we go to RLC, which is nothing but radio link control. So the purpose of this layer is to provide, error-free transmission between two nodes. In this case, nodes are GNV and UE. Similarly, once the error-free radio connection is being provided, the next layer comes PDCP, which is nothing but it handles the packet compression and little bit encryption of the headers. Then at the user level comes SDAP, which is service adaptation layer. Basically, 5G is a very improvement from the previous generations in terms of quality of service. So this layer was, earlier was not there. 5G, as 5G evolved from the previous generations, so these are some of the latest add-on is put into it. So all these latest solutions has been implemented in your lab solutions given to you. Okay. So if we see other internal detail, there is another set of protocols which is N3, N9 and N6. These are called tunneling protocols. Tunneling means a tunnel within a given protocols. So L1, L2, these are very standard physical layer data link protocol. And then layer 3 is the IP, which is a TCP IP layer. UDP is a transport layer. On top of that, our application layer GTPU runs, right? And then towards the end, it can connect your applications from UE to other applications on any external network. It could be MEC server, it could be any external data networks. So this is how data flows from UE to external network or MEC server. Some of the protocols which given, in lower bottom is called action interfaces. These are the interfaces between GNB. So in 5G, even the GNB can communicate each other without involving core network. If it is involving core network, then upper diagram is applicable. But in case of inter-GNB communication, action are the interfaces, and again these are using a similar protocol, tunneling protocol, and based upon TCP IP. Okay, so this is what is. Now let's come back to the very critical part of it. I explained so far the user plane. Now let's come to the control plane. And control plane is a set of protocols being deployed between UE and GNB and core. In core, AMF and SMS, these are two very critical, network functions which comes in control plane. Control plane means establishing the communication between UE and the cellular core. And GNB comes obviously as a intermediate node. So here you can see the protocols at the layer 1 and 2 remain almost same. We have a physical layer, we have a MAC, we have a RLC, we have a PDCP. But now you can see there's a difference. So for handling control plane, we have a RRC. In user plane, this was not there. Then on top of that, we have another protocol called NAS, non-access spectrum. This is divided further into two major parts. One is mobility management And mobility management deals with once we move from one place to other place, crossing the various boundary of cells or GNVs, right? Including even one home network to other home network. So what are the various control message flow that falls under mobility management, and the layer which handle this in terms of stacks is called NAS-MM. Once the other top layer, which is very significant, is called session management. Session management will take care of PDU session establishment, and then if required in between, it could be PDU management. And then towards the end, once the session is complete its objective, the session can be released. So all those control flow are being handled at the both side, UE side as well as the SMS in the core. As we will move into detail, our team and me will be taking you through all this important, call flow in both the plane, control plane, as well as the user plane. So we'll come back to you, as we move along into the what you call bits and bytes, and see how these flows goes, and each layer what role they play. So with that understanding, I'll move forward for my current discussion. This summary, this captures nature of various protocols running from various protocol layers, which I have just discussed. So NGAP is a protocol between, radio network and core, and basically the nature of protocols, if you call what you call OSI model or TCP/IP model, this protocol runs at the application layer, and it is used for service-based architecture in core, which I explained you. And if you go to the implementation, so this particular layers extensively based on RESTful API. So RESTful API is a kind of, APIs consumed by HTTP2 based web protocols. And in 5G core, 5 web protocols have been adopted, in contrast to previous generations of core network, where they were earlier using other kind of protocol, mainly diameter or radius based protocol. They have been replaced with now service based architecture, and the interface is service based interface, and the protocol adopted is REST API. Although there are many other API flavor exist, but REST API is the best API in terms of communication efficiency, and it has been deliberated among various forums, and this has been chosen as the best, and we have taken this API in our core implementation. And as the name says, they have been used between AMF, SMS, UDM. Let's go to another critical protocol, which is falls under NAS, and this protocol is work at a transport layer, layer 4 of TCP/IP OSI model, basically used to transport user data, and the functionality implemented using tunnels between GNB, UPF, and data network. So this is a second category of protocols. Let me go to one more protocol, which is between, again, at layer 4, and this manage between, you can say, between SMF and UPF, control the sessions and mobility procedures. Tunneling protocol is used in user plane, and again, passing on the controlling message between SMS and UPF. The other very important protocol is SCTP, which is basically, if I talk handle the control layer, basically UE signaling plane. This is being used, passing on what you call error-free UE signaling. So it handles various registration sessions, PDU sessions, handover, all between GNB and AMF. Very, very important. If you remember my previous diagram. And last but not least, which is used among various network function within core, it's a HTTP based protocols, operate at layer 4, reliable signaling, provide reliable signaling transport among various network functions. So this is the summary of protocols being deployed at our lab between various building blocks of the 5G infra. So how the network connectivity achieved in 5G? The network consists of multiple nodes responsible for radio access and providing the core network functionality as well as user data routing. So these nodes communicate with well-defined interfaces and the protocols which I just touch upon. So if we talk about, there are three major components. One is user equipment, which is being possessed to communicate. It's a equipment owned by end users, right? And then variety of user equipment comes starting from a smartphone to a dedicated kind of user equipment like 5G peripherals, which we have talked about. The second building block, node connectivity, comes the radio access network, which is in terms of our lab RU and the monolithic GNB, which is composed of DU and CU. Then obviously the heart of the whole 5G network is a 5G core, which provides, many important functions like starting with authentications of the UE, registrations of UE, then provide seamless connectivity as user moves from one place to other, provide various sessions related controls and maybe even enforce many policies related to charging and subscription services. So connectivity between node is RAN connectivity, which is core is called NG interface. I already touched upon in the last section what is the nature of NG interface. Okay, and within the core, the primary nature of interface is a service-based architecture. I already discussed that is based upon HTTP2 and the API deployed on HTTP2 is RESTful, right? And it provides the internal core interfaces. Now, the next important concepts to understand the implementation of the solutions is how we are virtualizing the 5G various we talk about service-based architecture. The service-based architecture, nothing but application is broken down or the 5G service is broken down in easily manageable microservices. And these microservices are popularly known as containers in our context. And these containers have been managed through again open standardized containerized platform, which is chosen for our solution is Docker. Okay, so this is what virtualization is achieved using Dockers. Docker play a very important role in deploying, managing, orchestrating the virtualized 5G component. And so 5G containers all, whether it is AMF, whether it is SMS, NEF, all dozens of network functions, they have their own containers. Container, if we can understand simply, is a kind of environment which have all the required dependency within itself. So it have all the required, whether memory or a compute or any other dependency within that. And it can be deployed, with the help of Dockers very comfortably, anywhere, anytime. So that's the the basic advantage once we use Dockers. Complexity is from the applications are being simplified with the help of containerized based solutions. Similarly, even our RAN, which is DU and CU, they have been also containerized. So that is the latest, you can say, the solutions, even in RAN, which is supposed to be very compute intensive and have been also achieved through containers. So which make it again very simple to manage and deploy as compared to other non-container based solutions. The last but not the least, the edge computing, which make this 5G setup extremely powerful uh, and forward-looking infrastructure. It have add-on compute, networking, and associated what you call virtualization platform, along with some pre-built, microservice-based applications for the analytics, which bundled already with our solutions given to you, mainly for IoT devices, W4S and industrial applications. This compute can be deployed. So if you see overall, this solutions is very powerful, uh, and it give a lot of opportunity to all of the institutes and researchers to make use of it and contribute towards the 5G applications. So this platform provides rich environment in terms of compute, in terms of what you call a platform and some of the pre-built applications. So with that, I am able to conclude my first part, which is introduction part. So now I will move on to individual component into little bit detail. So is this comfortable so far? I need to get a feedback from some of you. Should we move forward? Hello. Any questions so far? Hello.
Requesting any professor or student to confirm. Hello. Sir, I guess
Hello.
we are good to start.
Okay, so let me move on to the next section. Now we will drill down further level, starting from the core, which is you can say a command center of the whole cellular network. We will talk about 5G core functions and how they are implemented in our solutions. So that's the focus of the next section. So let's see what is the core principle behind core implementation. As I already touched upon when I was discussing during the previous section, the 5G core, as recommended by various standardization body, including 3GPP and AXI, they have recommended from previous generations that Lux core network should be more flexible and should utilize state-of-art architectural element which are being deployed elsewhere. So this motivation comes in 5G core network to adopt those already successful in hyperscaler environment like where this compute architecture and networking has been been virtualized even 10 years back. Why not to take that proven concepts in even in cellular network? So all the standardized body have agreed to support this. So henceforth, our solutions compliance to the latest architectural uh, style, which is recommended for 5G core, which provide basically high throughput, low latency, and the last word which I'm trying to emphasize, robust scalability. The service-based architectures provide very excellent scalability. It has been proven without doubt in many other implementation other than telecom. So that's why this good practice has been adopted even for cellular networks. Okay. So based upon that core basic principle, which is service-based architecture, the other various successful principles which have been deployed to simplify the complexity of the complex network is called control and user plane separation. So same principle have been deployed in cellular network, and you can see in 5G core architecture, which I explained you a couple of minutes back, there is a separate control plane and separate user plane. So that's another excellent architecture proven concept which has been adopted into the cellular 5G networks. Okay, so that simplifies the design which achieve throughput, latency, as well as scalability. So based upon these two key, rather third principle, I also would like to tell you virtualization. Virtualization is a concept which, separate between hardware and software. Earlier, this hardware and software were intermixed. They were difficult to change underlying hardware or vice versa. But this architectural concept, which is called virtualization, help achieve even reducing this dependency between underlying hardware and a software to the bare minimum. I will not say it has been removed zero, but it's bare minimum. And this third principle is again very good, what I'll say, very good practice which has been adopted in 5G core. So these three building blocks, which I say service-based architecture. Number two, I told you the control plane, user plane separation, and third one is virtualization. So these three concepts in this network functions, which is how we talk about in AMF, stand for access and mobility function. We have management as well, will be their key functions and user plane function. Okay, that is must to do user communication. We also include LE to achieve better, manage control of this. We have a policy control functions and the one other aspect which I just forgot to mention, 5G come first time in cellular generation, the concept called slice. So slice is the highest level of virtualization at the network layer. So it basically these concepts allow what you call layering of virtual network under same physical network. It provides multiple virtual networks. Each this network can provide you a very customized kind of services. Example could be the same 5G network infrastructure by implementing multiple slices at the same time. This 5G infrastructure can be customized to meet diverse need of like low latency and high reliability called URLCC for one kind of application. At the same time, it can also achieve the other high throughput applications like eMBB, and obviously it can also create a network slice to meet machine to machine communication. So this is the first time this principle has been in 5G been achieved. And our solutions you will be seeing in, we are providing this facility as well. We are providing 3 slices in our solutions, as we will see as we go into more details. So this is here comes our implementation of 5G core, which already have all those core network element which I was just describing to you. This is our solutions. You can see we have a RAN server along with this IP addresses, which you must be knowing. We have implemented slice. Our slice, you can see this. We have multiple, SMS and UPF to cater for various kind of slices. And obviously we have one slice for external network like internet kind, and the other slice has been created for MEC server, which is called XDN Edge. So this is one of the key unique USP of 5G, which has been provided to you as part of our solutions. I already touched upon these, functions. So maybe I'll not read it again. Otherwise, it will be duplication. The only thing I'll repeat some of them, which is not discussed. AUSF. Okay. As just this function is for authorization of the users, which before consuming any network resource, network is just verify identity of the users. And AUSF, which is in 5G network, it's a separate functions has been created. Earlier, it used to be, intermixed with in many network functions, but that was not a neat and clean solution. But in 5G, this function has been carved out separately with neat and clean interfaces so that AUSF is more effective, more powerful, and it interacts with other associated network function. One side UDM, which retrieve the authentication data and support various authentication methods. The other side, it interact with AMF. So various kind of security and enhanced security architecture has been, implemented with the help of AUSF in 5G. Okay, this is a significant security anchoring, you can say, network. So whenever we talk about security in 5G, AUSF will be the center focal point. UDM is tasked with managing the user data and subscription. It stores various kind of data related to user profiles, subscription details, authentication credentials, and many more. So UDM provide consistent and efficient handling of user data for different network functions. So this is helps to achieve central management of the repository, including personalized and seamless service delivery to each individual users in 5G. The UDR, which is accompanied with UDM, the UDR basically, as the name suggests, is a repository. It's basically a database, and it stores and managing network data. It provides unified solutions for all type of data, whether subscriber, network configurations, service-related information. The purpose is it provides a consistent platform across various 5G network functions. So this is a central repository. If you want to compare with the previous generations, to UDR and UDM, you can compare with the previous generations of HSS and HLR. Okay, not exactly, but very, very approximate mapping. Then obviously the very critical function is called session management, and as the name suggests, establishing, modifying, releasing the session.
तो भाई आप
आप हो रहेंगे क्या बोलते हैं
हेलो।
विटनेस रहेंगे आप विटनेस रहेंगे देखिए से हो रहा है मैं बोल रहा हूँ ये बोल रहा है कि अपने घर से कर रहे हैं अरे तो कॉन्फ्रेंस हो रहा है ये नहीं। तो मैं बोल रहा हूँ देखिए से हो रहा है ये बोल रहा है घर से कर रहे हैं तो मैं बोल रहा हूँ कि शर्ट लगाता हूँ हाँ function which are implemented in 5G based upon service-based architecture, which has been chosen and implemented in our solutions. So I already discussed. I want to recapture and show you as a summary. So this diagram shows the top are control plane functions, which I already described. I'm not going to repeat their name. And in the bottom, we have a user plane function uh, uh, connecting UE with the RAN and UPS. And there is a very minimal interfaces between core and the user plane. You can see only N1, N2, and N4. These are the interfaces between these two. Otherwise, rest of all been implemented as a service base. Single protocol is good enough to understand, various combinations, which is we already talk about, which is RESTful API base, HTTP2, very proven web protocols that has been, adopted. So henceforth, making this core network very, very uh, you know, easy to understand and many complexity has been solved. Otherwise, in previous generation, there used to be very complex point-to-point interfaces, including dozens of protocols. The job of an engineer or an administrator who used to do this was very complex. So the 5G core network has been very, very simplified using this advanced concept. So, okay, I'm just moving with this summary. I'm moving to the next one. So, just to, compare, this used to be, adopted from the previous generations. But as I told you, we are not using this reference point based solutions. The only, you can say, the bottom 3 or 4 interfaces are which are not so far converted into as well. Maybe as we move into the future generations, in maybe 6G, some of these even interfaces may be service based. But this is a state of art today. So let's go a little bit deeper into the what is this API between network function. So all control plane function, as I was explaining you, between any network function in the core, they have been using the service based interface. The protocol underlying to achieve the service-based interface is HTTP2, which is very proven protocol used in web domain. Okay, so the same protocol has been consumed here. But again, in web domain, there are multiple implementations. When I say implementation, architectural style underlying, which is being chosen here, is a RESTful. So RESTful is nothing but a short form of representational state transfer protocol. So this protocol has been chosen. There are multiple protocol exist, very similar, like SOAP based. There's another, complementary protocol, but they have been not chosen in 5G core. So if we go into this API based selection, the beauty of this protocol is it is so so powerful, and it use only very few primitives. The primitives which are being used are here as goes post. The post is a method which allow you to create a new resource at the server side. The right patch is a additional method which allow you to update the earlier created resource at the server. Delete, obviously, it allows you to delete. And here is another this, what you call, if I map down all these methods, how I'm using into my network function. So I have taken a very sample example, otherwise list is exhaustive, how the UE context management will be achieved using this, API, and these will be used in between UE to various, internal components. Create a new UE context, maybe AMF may be creating in what you call, using this method, throw UDM into UDR. Post is to, create, put is to update, right? And so these are the combinations which are post is using to release an existing UE, and put is used to create a UE new context, and then post again you can assign and context to UE, then transfer. All these what you call different methods are being used in our internal message flow between different functions. And this list is not exhaustive, just a sample example. Similarly, let me show you another case where how this will be used. This is for session management. So post, you can see post is an extensive method being used, and the URL, as you know, URL stands for resource locator, universal, and this is a very standard terminology being used in HTTP protocol. So it creates a new session context, and similarly it retrieve. So all these methods, how they are being used in our protocols. I'm giving just a sample example. So we can now move on to the server specification, which is used in 5G core. Although I touch upon in my what you call introduction, but I will go a little bit more detail now because we are going to drill down to 5G core. So 5G core is equipped with the very powerful Intel-based Xeon Gold 3 Dell servers. It comes with 32 GB of DDR4 memory and storage capacity almost 2 terabyte into 2. That means 4. BIOS setting here is default. Operating system, I already explained, Ubuntu. Kernel is runtime, and then Docker, we are using version 26. And its companion Docker Compose, which manage and orchestrate, is version 1.29. Server IP, if you notice, is 192.168, and X will vary institute to institute, and last will be 20. And obviously, NAT mask and or gateway will vary, but NAT mask remain same for everybody. In terms of this, we are enabling IP forwarding is enabled to make the seamless communication between different internal, nodes of our 5G lab. So this is containerized code, language for programming the various, containers code is C and C++, and dynamic threads are being pulled. The interface which has been achieved, standard interface, and they are used by SBI, which I already discussed in the previous slides. Okay, the slides achieved for our implementation currently is 3, and their detail is slice number 1, SST is identified as 128 and SD is 128. Slice 2, SST1, SD1, and slice 3, 130, 130. Then the other parameter is our APN slice wise. So each slice is given a unique APN in our implementation. So slice 1 is glab1, then slice 2 is GLab2, and obviously the core nodes implemented so far goes like this: AMF. Then we have a NSSF, session management, user plane, UDM, UDR, another PCF, then external network, IMF, AUSF, AULCL, NEF, and AF. These are the typical functions which implemented in code. Let's see little how they look like at our screen. Although my team after my sessions will take you how these different nodes are being made to run using various commands. So I will just at the very top level I am going to discuss, but detail will be done hands-on. The core network functions are deployed as containerized applications which run on core servers via container orchestration service like Docker. To view container image which are used, we just give a very simple command. Okay. And to see these are the commands which hands-on will do. After my sessions is over, we will do demo it all these commands and requesting all the institute. You can also do similarly while we are doing here. And if any institute fails problem, so we can connect each such institute and then guide them as part of training. Okay. So we go to respective directory and then we run these commands to run this. So I have just given taken this screenshot using Docker image. This is a command which we implement typed. You can see to the right side of my PP this slide. It talk about Docker image, and once this Docker image is typed on your core, you will get so many listing of the all images. So this is just for a quick reference. We'll do the hands-on. So I'm handing over to Dax, who will do the hands-on.
Just to check all these Docker images and different network functions, I'm just opening in terminal and demonstrating you how we can check the same. First, I have opened the terminal. Then I am doing SSH with username suadmin. IP is 192.168.2.20. So this is .20 is for our core network at every institute, and .2 this is X value, and it will vary from each institute. If anyone is sitting in front of system, then they can also parallelly type these commands. So this is how it looks. So if we do ls, so there must be a directory present named W4S core or W4S directory, where we have installed. So basically, this is our core network, and if we want to check all the images present, for that we can just simply type Docker images. It will list down all the network functions installed in your system in the core network. So this is a live demonstration which we have shown currently. And apart from this, you can also parallelly check process state of all the Docker containers running parallelly. So it has already been up for 13 hours in healthy state from 13 hours. This is a state of different network functions deployed in our core network. Hands-on tool we will do it later. This is just a live presentation.
So
Yes, you can tell us.
So as just Dax was explaining you, so we encourage each one from your institutes. You can do this hands-on, and Dax and the team will be, giving 2 hours to you today to compute this and do the hands-on under our, any help guidance. So this is just a, cut and paste from the screen, and how they been named in our case. AMF in our solution is called W4SMS. The name itself signify SMS is having multiple, containers because of the multiple slice. Same goes with UPF. So we have multiple UPF for each slice. And obviously we have each images for NRF and NEF. Okay. So let's see how the servers are provisioned and installed. OS and virtualization software installation is being already done in your institute, virtual machine for each network function. And these are some of the, picture I'm just putting here. You can very well physically visit your lab and see various LEDs and which indicates system power up, health, and drive status. So I encourage each of you to have a look in your lab. Okay. So maybe if you have any query or doubt, so we will do it online as we move into the what you call hands-on session. So this is again how to do login into MEC machine. Okay. This is how to start core, and again this is a simple code. Command I'm just listing here, and we'll do it from the live terminal once I finish my part. So just give us some time. We'll come back to you. Do the hands-on session with you. So here, what we are doing, we are going to the current, directory on a core and then running a command. Because this is a containerized application, so obviously we have to use Docker command. So Docker compose is a command, and these are few of the what you call flags or options to run it, and tell him the configuration file to be used, like compose W4S .yml is the name of the file which you need to tell him to run it. And then once all the core services are run, how to check whether they all are running or not is another command, docker -ps. These two commands just explained by Dux. We'll come back to you again in more detail. If any student have doubt on this, please put your queries either into chat box or you can always call us. So we'll be doing this hands-on. So this is how the network is configured in your labs. The only difference will be the X. Okay. Now, there are certain configurations file which are also part of the core network. And these are specifically very important because all the, subscriber, here subscriber means my user equipment, whether it's a two smartphone given to each of you or any IoT device, whether drone, whether 5G camera or IoT gateway, CPE, well board. All these devices have, SIM card. So SIM card is typically pre-programmed in our case and given to you, and their counterpart of data is being, populated in core server. And as you know, you must have remember my discussion like UDR and all that database. So some of these files are being configured at our core, and the element which we have kept here, they are related to subscriber ID, authentication vectors, and service profile, network slicing configurations. So these are some of the core configurations files which comes along with the core implementation. So this is how if you want to have a look at it, and anytime in future, if any student need to, customize, so this can be done in this directory, right? And the steps to view, you are encouraged to see the various, database element, and if required for your institute to, customize with respect to this, so this is the way we can do it. Okay. But let's be very careful. Very careful. We should not be disturb this file unnecessarily if you don't need to do it. Otherwise, this may lead to not working of systems. So I give you caution. Although these configurations file are given to you, but at the same time need to be careful once we are, changing these configurations. So this is what is the network API and interfaces which we are using. These protocols have been summarized. Like N1 interface is being used between UE and AMF, and basically it's a protocol is non-XM, and I explained in my architectural discussion. This is basically divided into two parts: mobility management and session management. Okay, similarly, N2 is the interface being used between AMF and GNB, and this network interface run on top of SCTP, which is another reliable protocol which run on top of UDP. And then N3 is basically for user plane, and it is between GNB and UPF, and the nature of protocol is GTPU running on top of UDP. And the other important is between SMS and UPS, to manage sessions between SMS and UPS. The name of interface is N4, but the protocol on this reference interface is PFCP. Okay, even if you recall my discussion, we have already discussed even in section 3. I'm just again repeating because it is coming here in core. So nature of protocol is the N8 and subsequent interfaces which are part of SBI, they use HTTP2 protocols. Okay, and to view the network messages, typically we will be deploying these utility and tools. So we are listing here, but this will be covered in detail about this in chapter 8 and 9. So Wireshark is a very versatile tool which will be we be using multiple times, either to live monitor the performance, or as well as offline and do the analysis or fault diagnostics for any network problem. Sigma ML is another powerful tool is being given to each student for running on UE. This runs on UE. Wireshark is an open source free, you call logging and monitoring tools. Okay. In addition to these, each core and RAN containers have their own extensive log files. So once these image runs, they on a runtime they create very, very detailed log files. And again, these log files can be customized at various levels, starting from very, what you call summary level to very verbose. So, live containers are being set to bare minimum so that performance is not compromised. But in case some need to be done, so always this log level can be changed and rerun the services. So this is what multi-level logs is. Okay. So this is what summary which is as part of this. Any questions so far on core? Otherwise, I'll move to RAN. Hello, any student? Any input? I'm moving over to Zen. If any have question, you can stop me or you can type in chat box. We'll come back to you. So in this particular topic, I'm going to describe the architecture of our solutions, then various subsystems implemented, features and functionality of each subfunctions, then our server specification for both the component like RU and BBU, then how the detail of implementation, then obviously at the very top level, how we can configure Node G, because Node G comes along with various radio parameters. So how those radio parameters can be, chosen. And as you know, radio interface of 5G is a very extensively complex and it highly customizable depending upon the nature of labs. So we'll talk about how to make it configure for our lab purpose, because 5G comes in multiple frequency bands and various kind of associated, numerologies and many parameters. So we will discuss that as we go along. Then obviously different layer of RAN and their detailed function, although we touch upon very summary level in the beginning and very detailed coverage, including various channels deployed, logical, transport, physical, we will do that, and their mapping. So this is the RAN part, which we are going to cover in next maybe 1 hour before we conclude for the first half of our presentations. Then afterwards, we'll go to the hands-on session. So let me move on to overview of GNB. So GNB also is a very important node of RAN, and it's play very pivotal role in any 5G cellular network architecture. Its role is to facilitate wireless communication while providing essential infrastructure to support high transfer rate, low latency, massive connectivity. Okay, so this is a progressive, GNB which will keep on, evolving as we move into future. So it compromise of control unit, distributed unit, and RAN unit. Its architecture design is again to uphold the high data rates, low latency, and massive connectivity, and at the same time provide varied deployment, needs of the end users. GNB leverages advanced technology such as multiple input, multiple output, making more and more, throughput. Also, at the same time, achieving network slicing to ensure optimized and versatile that meets diverse application requirement, which is the way of 5G need to mandated to support multiple, slices, whether it is eMBB or URLCC or MMTC. So all three profiles supposed to be supported by GNB. So this drill down of GNB, in our solutions, GNB is basically broken into two major building blocks. One is called RU, which is capable of 2x2 MIMO. Then we have a front-end eSPRI based interface. And then obviously we have a merged version or monolithic implementation of CUNDU. So if we see top level building blocks in RU, basically we have two major building blocks, low-fi and RF. Low-fi means lower level of physical layer functions, and RF is a radio function. These two functions are being combined and implemented in a dedicated unit RU, and this is connected on a very high speed front end called eSPRI, and through that we connect to the rest of the GNB, which implement rest of the layers, including Hi-Fi. Then we have a MAC, which is called Media Access Control, radio link control. Then in case of what you call uh, control plane, we have the PDCP and RCC. In case of what you call user plane, we don't have RRC, but obviously we have a PDCP and an SDAP. So this is a top level architecture of GNB. So this is a description which I just explained, and let me go to directly to RU part. RU utilize advanced antenna technology, massive MIMO allow, but in our case, 2x2 is the extent to which we have gone. Although there may be in a state of art, there may be even higher MIMO, but our RU is designed to take care of this much. This improve capacity and coverage. In addition to this, RU powerful, RU low power, and then we have the other BBU functions which achieve through DU and CU, and this, although this can be splitted, but in our solutions these are very much monolithic. DU handle real-time functions while UV handle non-real-time BBU functions. That is a very simple distribution among these two units, although in our case they are merged into the single container. So let's go to now features. So key features of our LAN system is enhanced broadband. So enhanced broadband basically, as all of you must be knowing, it provides us high throughput data rate. And as we show you in the demo, we have achieved very high data rates, both uplink and downlink. Then the second features is to achieve low latency and reliable. So this is basically meant for critical applications like flying of drones or another kind of UAV, or what you call C2X, car 2, I mean for autonomous car driving. So such applications need this kind of communication features, and our WAN along with RU and CU is very much support this kind of applications. Then we move on to the third kind of applications, which is called massive connectivity. The focus here is not on what you call latency improvement, but here the focus is to connect very high number of devices. And situation could be IoT smart city, where within a few square kilometer you need to deploy million of devices. So how such extensive device connectivity can be supported? So that's the comes here. And in many devices are very low power. The challenge is how to optimize power consumptions of such devices while at the same time ensure reliable connectivity. So that function is optimized under this profile. Extreme system capacity required to achieve this, like EMBB, extreme throughput is needed, and you need very high spectral efficiency, and obviously coverage is required. And then if you go to URLCC, for mission critical applications, you require low latency, high reliability, and obviously require very precise locations. For the MMTC, highly energy efficient, high connection density. These are the typical characteristics of this application. Obviously, extended coverage, because if there are so many million of devices connected, they need to be spread over not in few meters, but it will be in kilometers. So now, what are the WAN subsystem features? I will go on to now radio part. The radio part support
signal modulation and demodulation, which is a very first critical part of any radio functions. So it converts digital data into radio signals for transmission and vice versa. Then we have a very powerful antenna management technique nowadays, including beamforming as well as MIMO. Then, as we know, all 5G is not a technology which only works through frequency. It have multiple bands and in many frequency range, starting from sub gigahertz to 6 gigahertz, even to 26 gigahertz range, called millimeter wave. So to handle such a wide variety of spectrum, frequency management is a critical functions, and RAN is the entity who primarily play a significant role here. So frequency management is a very obvious critical part of it. Then, in addition to that, we have a radio resource management, and again, this is a critical function, and four pillars of radio resource management is scheduling. Scheduling basically decide which time slot frequency need to be allocated to which users and in what network condition. I mean, if there's a low SNR, then probably some better scheme can be suggested. If there's a poor, then obviously, so it's depending on the actual network condition as well as the user requirement, scheduling play a very important role. The next critical function is power control. So power control is a optimization between two opposing parameters. One side, it need to minimize interference. If to minimize interference, we need to keep the power between two receiver and transmitter to the bare minimum so that they don't interfere to other users as well as to their own receiver and transmitters. But at the same time, the second parameter is optimize energy. As you know, all mobile devices, they are very power hungry, as all require a lot of compute. But at the same time, battery is very, even to the best of state of art, even battery, even today, are not, so sufficient to handle all. So idea is to optimize the battery life of the user equipment. So this is a very critical and delicate balance which needs to be achieved. And to achieve that, there is extensive power control methods being, implemented in various generations of cellular network, and 5G have been more and more, efficient than earlier generations. Interface management mitigate the interference from other devices and cells, and again, various advanced interface management schemes has been chosen and implemented in 5G, and we also support all those chosen methods and implemented in our RAN solutions. Admission control, as the name suggests, it controls number of users to be admitted, seeing the current network congestion and the network condition both. So this is the second important, critical function of radio resource management. The third one is related to the uniqueness of mobile cellular network, which is handling the mobility. As the user move from one cell to another cell, idea of GNB is to provide seamless connectivity. That means call should continue without any breaks. Users should not even perceive there is a handover. Call continuity with no or minimal gap is the objective of handover control. Once the connection is not there, when the UE is although in the network, but they are not communicating. There is no call. It is called, say, that time also cell need to select, reselect while moving, although not in active state. So this is that functionality which also implemented. Last but not least is the location. Track the location of the user and for mobility and location-based services. Okay. The other component which the node will play important role related to quality of service. So it prioritizes traffic between various users based upon their prescribed QoS as well as ensuring critical applications need and their slice wherever they required. So this is a QoS, and 5G plays very significant importance to this, and accordingly GNB also implement this along with very close coordination with 5G core, which we have discussed earlier. Similarly, it to achieve the goal of minimize latency for real-time applications. The other critical function is bandwidth, effectively utilization of the available bandwidth among the various users based upon their needs and the service agreement between the users and the service providers. The other function is security of the users and the network. So 5G provide authentication and authorization of all the users connected to it, and basically it do mutual authentication. Network authenticate users, and users authenticate network, which were not there in the previous generations. So this is this, and not only the authentications, even the data which is being flowing between users through network, that should be secured. That means no unauthorized persons able to intercept, and obviously required very powerful and advanced technique. So 5G core along with GNB achieve this goal and use powerful encrypt and decrypt algo as suggested by various standardized protocols for 5G purposes. Like we very well support 5G AKA, which is the current standard for the security functions, as well as the security key management. Both the functions are achieved by implementing 5G AKA protocols, which has been also chosen in our solutions to implement this latest security guidance provided by 3GPP specifications. So our solutions is very much compliance to this 5G security guidelines. The other highlight of RAN solutions is supporting 5G unique feature, which is slice. So it provides slice isolation. That means two slices will not interfere with each other. And that's what is a key objective here. Not only the performance, but at the same time, security. Both the slices, they operate independently in terms of performance as well as security. The security of one slice should not compromise the security of others. So that's the objective. And then obviously the physical resources are optimally allocated among the slices based upon their need. Obviously, if there is a URLCC, the priority will be given to URLCC slice in comparison to the other slice, which is called EMBB. So appropriate resource allocation among various slices is also a need of 5G feature, and our solutions very much implement network slicing support. Okay, so then we come to data aggregation and processing. As you know, we have provided you very powerful compute in terms of edge. So we can do edge computing at this, and provide the data processing very close to user, and which will helpful to the user latency of the applications. Okay, and then data aggregation, we can provide data aggregation from multiple devices before we forward to networking. So this is the key features of RAN, and the last very critical is synchronization. The 5G network are very time critical, and then their performance is affected if there is any error related to synchronization. Time and frequency synchronization have been achieved by various schemes implemented in our solutions, whether it is PTP, P2 sync, all required synchronization is being chosen rightly and placed in many building blocks, including from RU to GNB. And maybe some of there, if required, synchronized with NodeWorks. So here is the now after knowing the specification, the features, let's see the what kind of underlying hardware and software there to achieve this. So server type, this is a very powerful Intel core chosen for this purpose, and along with the memory. As you know, this device is a real-time device. So focus is to achieve real-time performance, not the offline storage. So henceforth, you will comparatively notice storage is not very high as compared to other servers, but the focus is to optimize real-time performance, and henceforth all the attentions to this core architecture is optimize real-time performance of our DUCU, which is very, very extensively real-time application as compared to other network function. And this is achieved right away from the hardware to the BIOS. Hardware comes at the very bottom of the layer, then comes the BIOS setting, which fit in between the hardware and operating system. It achieved optimization with respect to threading and various CPU optimization technique provided. Like you can probably customize CPU clocking. You can do some SRB, IOB network. Network interfacing cards can be configured in very real-time effective manner using this some very time efficient BIOS setting. Then we move on to the next layer. After the hardware and BIOS comes the operating system. So again, very careful selection has been done to choose the operating system, keeping two things in mind. One is openness, so that we need not to do any proprietary operating system. So it's an open source. At the same time, we should not compromise real time. So henceforth, after long, experimentation and research, our team have narrowed down to this optimal solutions, which is based on Ubuntu and real-time kernel. On top of that, as we are already telling you again and again, we have chosen Docker as our virtualization platform. So henceforth, it is very necessary to talk about which Docker. Again, Docker's most reliable and stable version are chosen. You will see Docker again, it comes from the open source. And this open source has been, well curated by our team and stabilized so that it does not give any surprises as typically come with any open source. This has been extensively experimented, stabilized version of Docker for our purpose. The second component which comes is, as I explaining you, the very precise synchronization at the RF level between RU and DU. So there is a Linux service called PTP, which runs as a special service in Linux.
Just give us a moment, please.
हो सकता है 5 मिनट कम हो जाए.
We are back now. Yes.
Hello. So I'm sorry for 1 minute interruption. I'm continuing with my discussion. I was discussing about the uniqueness of synchronization between RU and DU, which is a very, very real-time front-end network. So there's a Linux service which is being deployed at the GNB side under the Linux kernel, which achieve this. It can synchronize based upon this server. This server job is only to synchronize the timing related stuff. Then network mask and all things are as per our specified IP ranges which we have agreed between multiple institutes. So this is repeating. I'm just moving to the next part. This is the deployment type. Again, RAN is containerized, which is the latest, I will say, feature of any RAN in 5G. Many are still non-containerized, but in our case, this is very much containerized even day one. Language to implement is C++. IP for this is when typically last is 10. 80 is put by mistake, but it could be varying from institute to institute. Okay, so UPF connection is this what you can say given for our slice, and 3 slices are implemented as on date. And architecture style for our implementation is monolithic. So once I say monolithic, on G and B, DU and CU are implemented in the single containers and they are not be decomposed by another split. Okay, so that's the uniqueness and this achieved a performance goal. It achieved better performance, so that's why it has been chosen. So again, radio type, which is a very critical technology in 5G. So it's an indoor RU. When I say indoor RU, this lab is meant for only in-building operations, and accordingly chosen RU unit is low power, and this we have configured this for a bandwidth 100 megahertz, and it's a single carrier, right? So no carrier aggregation here. It achieved 2x2 MIMO, and as this is configured in N78, which it is a around 3.6 gigahertz range. Okay, it operates on a single numerology. That means we have chosen sub-carrier spacing at 30 kilohertz. Although 5G supports from 15 kilohertz as high as 250, 240 kilohertz. But for this RU, the chosen is 30 kilohertz. Antenna in this is external antenna. The front haul media is a 100G over SFP plus interface. This interface have a capability even to PoE, which is power. It can charge on Ethernet. Okay, RF power as per antenna port is 250 milliwatt, and the split which has been chosen in this is 7.2. If you want 7.2 means physical layer is split between two. low, low-fi and high-fi. Low-fi, if you recall my discussion, is at the RU, and high-fi is at the part of DU. And the other specification of RU, like in terms of antenna gain, it is 6 to 9 dB. Now quickly, I'll just see some critical, steps which are required in RAN operation. My team will take you after lunch. Just after lunch, very detailed. So here are the sample key things which need to be done. Obviously, first step is we need to go to GNB server, and from there we run two important critical services which I was explaining you for synchronizing. So one service is PTP, other is P2SYS. These two system level services provided by the Linux, and these are the mandatory for our application to run. So henceforth, very critical. Every student and every lab administrator need to remember the criticality of these steps. Okay. So, and then we will demonstrate in due time to you. Okay. So then we need to, second step is we need to, there's a one, what you call performance script, which need to set many parameters as per the requirement of software. So again, instead of running multiple commands, for the convenience of system, administrator at the lab, we have put all the commands into one typical service, and we run it to make it all the CPUs set to the right performance level. Okay, so this is the step 2, which we do before we make GNV run. Then another third step is very simple. By this time, all institutes must be very comfortable with Spring utility, making sure whether our GNV is connected to core or not. And again, in after my lecture or discussion, we'll do this and demonstrate you again today how to do the reachability check before we run all the networks. It's a recommended step to check before whether all our building blocks in 5G are connected on the network or not, so that we run seamlessly. Otherwise, you have to come back, debug it. It is better to check before you make them operational. Okay, so step 4, then after we have ensured GNV is accessible and core is connected, now time to go to RU and do some, some configurations to use them. So this is the command to login. We will demonstrate you. I'm just skipping right now because I'm not doing simultaneous the demo of the command. As we were discussing, synchronization state of the RU has to be in a very proper way. So again, the cross-check whether RU is synchronized with the GNB or not is a very simple command. We actually doing nothing but reading a one log which keep log of the synchronization process all the time. So we just ensure, and the command for that is just tail -f. Tail is a utility which allow you to see the any log last few lines. Okay, and then we do a Linux utility called pipe, and this utility is grep. So we pipe grep into sync, and we are, grep is a command to search any specific pattern. And in my case, I'm looking for sync tag in this file. If you run this command, simply it will tell you whether our RU is synchronized with GNU or not. In this particular screenshot, you can see the same command which I mentioned, and obviously you can see this many places the word synchronize is appearing. So that's a good indication that RU is currently synchronized with the GNB. And this is the mandatory step to make it our 5G lab running healthy and achieve the desired accuracy and synchronization. Okay, then one more step before we run code, make sure whether we have chosen the appropriate antenna configuration. Not miss anything before. Should I continue from here?
Yeah, please continue.
Okay. So this is another step which is required to run completion, and the command is again sudo and ru completion enable script file, and we'll demonstrate you once this is over. And last is how to run GNB with wires or logs if required. This is the command, Docker command. So don't worry about it's so lengthy command, but at the same time very easy to done at the runtime. No need to type. It is again can be done easily. So I'm just listing this command and will demonstrate you how to run GNB with Wiresock log enabled whenever it is to be done. And after we
Slides are not changing.
Funny thing.
Slides are not changing.
Okay.
Just figuring out what is the issue, sir. Give us a second. This is the one, right? I think the slides must be visible now. That the slide is 5G operations checking logs 9 out of 9.
Yeah, it's visible now.
It's visible. Okay.
Sir. Just let me try to change it. Did it move to 8 out of 9 on your end?
Yes. Yes.
Okay, sir. Definitely.
Some issue our side. Sorry for disruption. So once we have run the GNB, now command how to check whether everything is running on fine. Similarly, again, we need to use the Docker services and see the Docker logs of the GNB. And this will provide you ample of information about what is happening at GNB node. Considering actually your GNB comes pre-configured from us, but if any student feel that they need to rebuild GNB, and configure, there is detailed procedures which will be mentioned in our use case lab, and we can demonstrate you. But today in training, I am not covering in detail. So please let us know for that. User manual and training manual are having this detailed procedure. If required, this can be discussed, but not it is planned today training. So now we will talk about the different layers and functions of this. implemented as part of RAN. So as I talk about in my previous discussion, the lowest layer in terms of implementation in physical, which handles transmission, receptions, modulations, error conditions of the signal. The next layer in hierarchy come media access control, and these layers very much, influenced by well-known network architectures, 4 layers or 7-layer architectures. It manages resource, schedule access, and manage schedule with between uplink, downlink with various users, and obviously handle errors and retransmission. Radio layers make sure reliable delivery and achieve through various modes called and do, if required, segmentation of the bigger message and reassembly at the other side. PDCP, which is called packet data convergence, basically it provides encryption, integrity, and header compressions, because the underlying protocols which are TCP based, they are very heavy in terms of headers. So to achieve the best, some headers are compressed before they are sending over to radio interface. SDAP basically comes in user plane, play a very significant role, and this is the additional layer which comes only in 5G, and it effectively allowed to handle various kind of QoS to data radio bearers, 5G specific. RRC is a layer which comes in control plane and nothing to do with user plane, and it handles all the signaling starting from power up of the UE to various signaling stages, including mobility and connection. Very exhaustive message into, and then we have another layer, NAS, on top of radio connection. Once is established, NAS handle typically the authentications, mobility, management, session establishment. So these 2 layers, RRC and NAS, together achieve most of the control layers functions. Now we are going to further drill down at the radio levels. Radio levels, as all of us know, these channels are nothing but at the physical layer combination of a frequency and a time slot. But at the logical levels, these channels achieve a specific, functions. So there's a mapping need to be established from logical channels to physical channels in 2 steps. One is between logical to transport, another is from transport to physical. The physical layer implements the real channels, which is very unique combination of a frequency and a time slot. But at the logical level, these are the functions achieved. So let's start with logical. So very first logical channel, which is called broadcast. It broadcasts information which are meant for each and every UE in a cell, as the name suggests. And these are some of the critical information which typically broadcast. Some are many times, some are at a specific time, depending upon the context of the need. Then second channel, logical channel, is sending paging message to for either for UE location update or for resumption of service. Once data sessions are suspended or UE is into not connected state, so these messages are you make to awake the UE and come back to the connected state. Then another very important is called common control channels. So these are control message, but more than one UE. Like one of the example is location update or a paging. Then we have a dedicated signaling between UE and LAN that meant for only for specific UE. Okay. And then another class which 5G also provide, which is called multicast services, multimedia and multicast. And obviously last is called carry user data. So these are almost half a dozen channels which have been designed to take care of the all needs of remote radio channels. And these channels are only exist on wireless channel. They are nothing to do with the rest of the network, only between UE and GNB. Okay. Then, you can see the number of channels are not exactly 101 in transport layer, transport channel, which is between MAC layer and the physical layer. So here the number of channels are reduced, 3 downlink and 2 uplink. You can see one of them for broadcast and others for common control, right? And then we have a shared link for downlink user data. Similarly, for uplink, we have for user data, which is shared. And the uplink, you will see another unique channel, which is called RACH, random access. So this is very important to achieve the initial access by any user device to the network. And a separate channel has been designed. And this channel is designed not for only in 5G, this carry legacy from 2G onwards. So to uplink, always we need a random access channel to access the network by UE for initial access. Then physical layer, as I was explaining you, this is the channel implemented by the low, high-fi and low-fi. And at this layer, this carries which is called physical broadcast channel, number 1. It carries system information at the physical layer as forwarded from the upper layers. Then we have a what you call user data and broadcast formation that goes shared channel. And then we have a scheduling assignment on control channels. Similarly, PRATs correspond to RATs in the transport channel, and it allow UE to request for channel first time when they are or even subsequent, but once UE have lost the connection. So every time when you need a connection, either first time or a second time, once you lose, this is the process to be done. And PUSH and PUCCH are carrying the user data to the network, and last for control channels. So these are the physical channels needed, and we'll see now their I'm mapping. This is a pictorial view. Top layer shows logical channels. Intermediate layer talk about transport, and the last layer talk about the physical channels. The one thing which I want to highlight and tell you about, some of the channels I have not even shown, but they are called physical channels. So these physical channels have been introduced. They don't play any role at the upper layers. They only use at a physical layers, and they are meant to achieve certain, functions at physical layer only. And these are typically DMRS, stands for demodulation and modulation reference signal, and other is PTRS, which is called phase tracking reference signal, and all these channels, physical channels, are basically meant to assist the reliable communication in any demanding situation, because radio channels vary from second to second, place to place. And henceforth, to get the actual real-time radio situation of the channel, these 5G has been designed to, inbuild dedicated reference signal to real-time measure and characterize the radio channel, and accordingly select the best possible scheme. So that's the purpose of this resource channel. This slide again demonstrate various kind of mapping from logical to transport, and here is a list of various channel and their purpose. Very first PPS SSS are the two synchronization signal which is used once you power on any UE. They go through two-step synchronization process required to synchronize between the GNB, RU and UE, basically for time and frequency. After these time and frequency are synchronized, UE and the radio unit of GNB, they know exactly what time and frequency they are communicating. Once this minimum synchronization has been achieved, the next level is to broadcast system information to the UE, which is just been powered on, to get hooked to mandatory systems parameter so that it can move on to some more channels required to communicate. So, UE is getting information in bootstrap manner. First, it is power up, only do the minimum synchronization, then get very bare minimum essential system information mandated in broadcast nature, and then using this minimum information, UE is geared up to get another set of information, which is in terms of SIVs, and those information make them know more about the cells, more about the other important physical layer parameters like power controls and things. Okay. Then let's move on to the other channels and their use. We have a physical downlink control channel, which typically, in addition to user traffic, also used for power control. As we discussed in our GNB feature discussion, power control play a very significant role to optimize interference and as well as the throughput. And then we have physical downlink corresponding to user data. Then couple of reference signal which I discussed, DMRS, PTRS, CIRS, they are meant for achieve signaling between physical layers of radio unit and UE. Then we have a dedicated channel called PRAS, which is used in uplink channel to achieve the initial access between UE and the network, also called uplink synchronization. The downlink synchronization is the first part, which is a primary, secondary, and this is the uplink synchronization. Once this uplink synchronization is achieved, then UE move forward to do control signaling between UE and GNB. And obviously, once this has been achieved, the required signaling between UE and network has been achieved, then UE move on to sharing the user data in the uplink. Okay. And to achieve that, I just mentioned one more, what you call reference signal is called SRS, sounding reference signal, to check for uplink channel measurement and some minimum time sequences synchronization and beam management. So these are some of the physical layers channels at both the plane, control plane as well as the user plane, to achieve the desired communication over the air interface. So here it shows, summary of the various critical aspects of radio plane protocols between various layers, from MAC to RLC to PDCP and SDAP in case of user plane, and in both way, uplink and as a downlink. So as you can see, as they have mainly handling calls, what you call QS flow handling, PDCP does security and header compression, as we discussed. RLC typically handle the segmentation of big message to achieve the goal of what you call reliability across radio link and do the reverse. And MAC layer do the multiplexing and scheduling of the all the traffic coming from the upper layers, multiplex them, and send them to transport layer, through transport layer to the physical layer. Similarly, if we go to the uplink, they do the similar fashion, but reverse. So let me go from transport layer. We get the transport layer message, MAC do the reverse, and then accordingly RLC check the segmentation, and if yes, then they do reassembly. Okay, and then PDCP do the required decompression if done, and security validations, and then forward for the uplink SDAF for achieving the receiver side Q flow mapping. So this is how overall things are moving in radio. The other important aspect which we need to understand is physical layer working fundamental concepts. We discussed physical channel. So what does a physical channel mean? You know, at the very minute level or at the very elementary level, all the bandwidth of an 5G radio has been divided into the smallest possible frequency component called subcarrier spacing or subcarriers. The red element in this current slide indicate single subcarrier, in our case, which is a 30 kilo bit per second, and the time element which consists of slot. A slot consists of symbols, and each symbols have almost 14 elements. So this is the minimum building block of a channel. And then how this hierarchy frame air interface. So we can see there are two dimensions depending upon the subscriber spacing I choose. And in my case, as you know, we have a 30 kilohertz, but subframe is remain fixed 1 millisecond, and slots, if there's a 14 slots in 15 kilohertz millisecond, so then time. Similarly, if we move on to multiple slots where move on, and as you can see from lowest level, which is 120 or 240 kilohertz, slot become very smaller, 125 millisecond. So you can see 5G provide us at the physical layer flexibility, choosing time slot as low as 125 microsecond if the latency requirement is very stringent, as in case of URLCC. Or we can relax it whenever is required in favor of achieving higher throughput or other optimization. So we can move as high as 1 millisecond. So that's the flexibility. Keep in mind in 5G air interface, which is called 5G NR. So this is we have taken from 5G NR specification and standard information available in public domain in 3G 5G specifications. Okay. So, and we have exactly implemented in our radio interface. So this is a summary of what this channel do. Logical channels offered by MAC to RLC, control channels and carry control plane packets as well as traffic packets on UP packets. Each logical channel map to one channel. Okay. Similarly, transport are offered by physical to MAC. MAC layer multiplex one or more logical channel to a transport, and same do reverse what comes to. Physical channel that carry on the air interface, as I explained in terms of subcarrier channel, and the lowest level is called symbols. And in term hierarchy goes to slots and whatnot, frames of frames. There are hierarchy in terms of time. And this is again a layer flow, how from layer 3 to layer 2, and it moved to physical layers in case of 5G NR radio. Okay, so very nicely explained layer 3 RSCC, how they move on to PDCP, and PDCP pass on to RLC and MAC, and I already explained how physical channels are allocated. So this I discuss various reference signal, how they achieve their role. Like in case of NR, there is no cell specific reference signal. All are unique to each UE. And a new signal have been introduced called PTRS, and it is basically to take care of the time and frequency. DMRS has been introduced both for uplink and downlink. And DMRS, you have seen in many my previous talk, they have been clubbed with the logical channels. In NR, reference signal are transmitted only when necessary, and not broadcasted like in earlier generations. So basically, this is a optimization with respect to previous generation, but concept remain almost the same as carry forward from LTE. Okay, so now let's quickly see the importance. Some of the important physical layer signals come for synchronization. These three together is called PCB block, SSB block, and three main primary, secondary, and physical broadcast. These three together are called merged in 5G. In earlier generation, they used to be independent, and they're called synchronization block. And similarly, in addition to this synchronization, and as I explained, these are physical layer signal. They don't exist at the higher layer like this. Then we have a DMRS. As the name suggests, this is a demodulation reference signal. Its aim is to, optimize NR receiver so that it can estimate the channel estimate and accordingly prepare receiver to work very efficiently and precisely for the receive with minimum errors of the channel. And this is specific. These channels are specific to physical channel, like DMRS is unique to broadcast channel, control channel, and as you can see, uplink and data link data channels, as well as control channel. And as I explained earlier, UV specific is there. As I explained, it does not extend outside the physical resource, and it supports multi-massive user, MIMO, and it can be used not only the MIMO, it can also be used to beamform. So it is very advanced stage of reference signal which make enable the latest RU features possible in demanding to achieve very demanding throughput. And the same is the other channel sounding reference signal. It is used in uplink, and it is again specific configured to UE. And as all these reference signals, they are only transmitted in a dedicated span in some signal. They are not, and this has been predefined by the standards and kept compliance in our design. This is another signal called CSI and used for measure. This works and used to configure a specific case. And obviously, this used to estimate the signal, what you call signal strength in real time to optimize and use the right amount of radio signal conditions and achieve beam mobility, beam management as well as mobility. So my last topic of discussion before we break up for the lunch is how this element core and GNB, they have been integrated together. Although the content which I will be using, they have been already covered in my chapter 3, but I will be quickly remapping them into the topic current discussion. So first of all, to integrate RAN with GNB, we need to configure their IP appropriately. So here is the summary how we have configured AMF, UFF, and these are the some of the given summary for RAN as well as core. And as we can see, X will vary from institute to institute. This is again for RAN and core, and this is the protocols deployed on this from UE to GNV to UPF and to the external data name. Okay. So in the let me just close this discussion. Then I will take the questions in the chat window. Okay. So summary of on server and UE is this. So this is how this is user plane level where UE have all the layers required to share the data, and counterpart GNB also have 5G capability like as the app, which is unique. Then we have a internal tunneling protocol between GNB and UPF. Then we have PDP layer management protocols running on UPF and UE. Okay. And then end-to-end applications will be running in UE and data networks. So this is the very logical and easily understood protocol deployed on server and UE. And this makes the basis of how we are integrating UE with the GNB and GNB in turn with the core. And core in turn enable to connect to the external data networks. So it shows end-to-end connectivity of the various components in 5G context. And this is a repeat, but it is for control plane as well. Okay. This is control plane protocols. This is a summary I already discussed in the first half. So I'm just in this part. Now, here I conclude my first session. And let me summarize what we discussed so far. After this summary, I will take your questions. So we started with the introduction of the 5G lab, their architecture, their building block, their implementation. Then I move on to deployment of various protocols in chapter 3. Then after understanding very top level protocols and their deployment across various components, we move on to very building blocks with core and GNV. Okay. And then in the end, we talk about how various building blocks are deployed, configured in the network. Okay. So this was the discussion so far. Now I am going to take your questions from your chat box. So let me go to your. Okay, so one question which is I'm taking up right now: how does 5G core enable network slicing? So, if you recall our discussion, our 5G slicing are implemented. That one is yours. So this is a question, question 3, which is related.
Give us a second, sir. Let me take up some time of opening, sir. Then
Okay, so let me answer your first question from the chat box, which is related to slices. And someone has asked why we need 3 slices. So first of all, I will answer in 2 parts. First is generic, which is network slicing is one of the features desired by 5G specification. So henceforth, we are complying that requirement. Now, part 2 of the question is how we have implemented. So basically, we are providing virtual support to meet different requirement of our application deployed. Like some of the applications required services like drone and some other MEC applications. So they require different kind of slides. So to achieve this, we have created multiple slides. Okay, and so that we can provide different services. From to meet the need of different applications from different institutes. Is that okay? The second question relate to UDM. So in 5G context, if you recall the security authentication protocols, which is 5G AKA, which mandate actually vector generation with the help of UDM. So that's why one of the purpose of our UDM is to achieve 5G mandated algorithmic which generate authentication vector. These are generated with the help of UDM here. That's the very specific purpose. Any other questions? The last question I'm getting, how does GNB play a role to provide high throughput? A very good question. Actually, the GNB along with RU is the only nodes which play a critical role to achieve high throughput and utilize multiple combinations of architectural element like choosing the best subscriber spacing, then accordingly choose the slots, timing, symbols, which can achieve at least one level of throughput. Then at the RU level, we have 2x2 MIMO. So the higher the MIMO order, we get the proportionally higher throughput. So that's the way GNB and RU give you the maximum capability to achieve the throughputs. And at the same time, it optimizes the latency as well. If you want to have lower latency, you go for a higher, numerology, where the symbol of minimum slot become as low as 125 microseconds. So that's the flexibility which 5G architecture has recommended, and our solutions is very much compliance. Okay, the other questions is what are the benefit of SBA with comparison to reference point? As I already discussed, let me again reframe. SBA is a service-based architecture, is an architecture which simplifies the complexity of network functions with respect to reference point. So we can decompose network functions into independent containerized or virtual functions, while in case of reference point, this is not the way. And the associated interface are again from service-based interfaces, which are already proven in other domain, and that proven nature of interfaces we have deployed in telecom, in cellular mobile networks. So that's the thing. Okay, let me take another questions where why eCPRI used instead of CPRI? Okay, I think the interface which you have chosen as 7.2x that require not less than 1 gigabit bandwidth. So henceforth, eCPRI is more than enough, and it is a Ethernet-based interface. So it is best optimized for our configuration. The next question is, where exactly CUDU present in the RAN? Okay, CUDU is very much part of our GNV, and they are one single container in our application. It is being hosted in GNV server. Any other questions? I think I am able to answer all. Other questions is, can you provide PPT? Yes, everybody will get the PPTs.
Yes, it is already
being there.
DOT. If required, I'm dropping support email in the chat. If anyone is. Last question. Sanjeev Kumar.
संदीप का क्या नाम है? संदीप का क्वेश्चन है। पता है। मेरे ख्याल से उन्होंने वो पूछा था।
Just
संदीप।
3 slices mean we can run maximum only 3 applications at a time. What these 3 slices represent? 3 slices doesn't mean different 3 applications. 3 different categories of applications.
If this answer is sufficient, otherwise we'll take it in more detail. So should we break for lunch?
Ramesh ji, please confirm.
Ramesh ji?
Yes.
Yeah, so we will get back 2 o'clock.
We will connect on the same link at 2 o'clock.
Okay, sir.
Thank you, Ramesh ji.
And then we'll skip chapter 8 and 9, which is hands-on. I'll move on to 10, 11, 12, covering that, and then we will come back to chapter 8 and 9 for hands-on done on the theory so far. That's my scheme. Okay, so with that, I'm moving to chapter section 7, which is an MEC platform. So various hardware which is being given to you as part of MEC platform. This is a very powerful compute platform given in form of MEC server. You can see it is very powerful in Dell server, having the Intel Xeon server grade compute. with enough memory and storage. Because this is a non-real-time platform, so BIOS is default. We are not so optimized like in case of G Node V. Operating system remains exactly same. Ubuntu kernel same, and software package in this case been like Docker, similar like other. Linux PTP not required because of this does not require close synchronization with any node, and IP and configurations are very much similar. Rather than each institute will have X different. Okay, so now what are the various MEC app which is being already configured on MEC server? So first of all, you need to power on, enter the password, and need to do different procedures for different ME applications. For example, like camera analytics, drone, and maybe IoT as well. So let me see for camera. The camera can be attached to 5G and in turn to MEC applications. So first, there are two major ways by which camera can be connected. Either wireless, which is a by default option, but in case some institute need to debug or want to connect, so there is an option connecting through LAN as well. So both the procedure has been listed here. So in case of camera, you want to connect through LAN, so power on camera, connect the LAN and camera in the same LAN, so static IP preferred, and just to give a ping to verify whether MEC is reachable. Once camera is reachable, so make sure by upper command, then we can run analytics. The path of the application installed at MEC is given in the command. Very similar process to wireless camera. Power on camera, insert what is 5G SIM into camera, and then 5G private network. We do this. Verify camera is connected via LAN, and we can verify its IP and on gateway through this command. So currently we have already installed MEC application related to camera, and we have couple of programs pre-written and deployed. First is for object detection. So the application named as make object, and then for face detection, we have another app called make detect, and within that, to make a sample, we need to do some what you call preparation. So in case of face detection, we need to start camera, make sure camera and you face in center location, and once done, once sufficient sample is captured, the UE camera will close. And once this is done, then go to step 4 and run the make predict. So if it is a successful step 3 done in step 4, you means the same person face again camera, and next time it will predict the right person. If it predicts right person, that means application is working fine. In case any problem, probably it may not be the right answer. Then need to debug what is same. So now procedure to route the traffic to MEC server from the device all the way to radio network to the GNB core and till it reaches the MEC server
Bhupinder sir,
and
just a
G.
minute. Bhupinder sir. So slides are not moving.
Slide is not moving. Okay, what happened? Daksh, I just moved next. Is it moving or not moving?
So can you just stop your screen and share it once again?
Okay, I'll do that.
1 second.
Okay.
Is it moving now?
Daksh?
Yes, sir, it is visible now.
I think it's visible now. You can continue.
Oh, it's okay.
Yeah.
Yeah. So I'll now continue. So let me just go one step further back. So I was here, how to route traffic from 5G camera device to the application, also the core and GNB. So first of all, we need to set some routes to traffic to reach the right place. So on MEC application, we need to do on core add the route so that it reaches. Similarly, we need to do on MEC. So the desired traffic reach to the MEC application. So these two settings need to be done on respective node so that MEC application is able to reach. Okay, so now let me just go how we achieve this. First of all, check the camera analytics by running application after connecting camera with private 5G network. Then we need to check Docker process state for the drone application running or not by using Docker command, Docker -ps, as we have seen in the morning. Daksh has shown you on the code. So similar steps. Okay, we need to check ThingsBoard dashboard, which is a open source IoT platform which been adopted, curated for 5G lab and check for census data running on MAC server or not. So this is ThingsBoard is an open source IoT dashboard which has been running on MAC server or hosted on MAC server. Okay. The last not least, we can even check from NMS whether MEC running on MEC running or the code server running or not. So this is the overall scheme where MEC fit into it and details things. We will be going through all these steps once we go to hands-on sessions. So let me go to the next chapter, which is 8. This chapter mainly hands-on oriented. So I'll not spend much of time here. We'll do it. I mean, just quickly, browsing for your attention. So basically, these are kind of tools which is provided to you. Log analysis can be done by Wireshark, an open source network analysis tool. Also a proprietary tool being given as part of deliverable Sigma ML, which is running as an app in each UE smartphone given to you. And in addition to that, we can monitor log of runtime consoles logs for all the nodes starting from core and GNB, and some other utility which are part of this Aruba, which in fact Aruba consists of iPerf for testing throughput and ping. Both these utility comes as part of Aruba. So this is overall scheme of that set of utility and tools given to you as part of lab deliverables, so that each institute is equipped to handle analysis at their own. If still they are having some problem, they can always welcome to connect back to us for any more subsequent expertise and help. But infrastructure is fully equipped to handle all kind of analysis. So this will be taken while we will do in classroom. Basically, it comes with a lot of network traffic filtering. It can support all the protocols which we have deployed in our 5G, whether it is the NGAP, whether it is a NAS, whether it is a tunneling protocol, whether it is a packet forwarding, or a last but not the least, the RESTful SBA interface. So the WireShark comes in all the flavors with all the desired filters. The other tool, which is Sigma ML, it's help in lot of measurements. The main purpose is it supports many type of FTP download and HTTP download. List goes multiple. It's very extensive tool. It allow to do lot of testing. Okay, including you can do web outgoing mail checks, email checks, measurement throughputs, real time delay, voice quality, and it can also help to measure various KPIs in terms of 5G, like RSSI, RSRP, RSQ. It's a very powerful utility in the end to check. These are some of the highlights which will you demonstrate in the hands-on sessions. Okay, so it shows information about the cell. It shows information about the measurement, different kind of measurement in context of 5G, including beam management or carrier aggregation, if at all selected. It captures a lot of information about various, physical reference channel, as we discussed in the morning, SRS, and various logical channels like upward control channel, uplink shared channel, CSI info. So it's very extensive. All parameters we can check through this Sigma ML tool. This goes along Aruba. So this very utility, we need to use it for checking throughput in both the directions, downlink as well as the uplink. The restrictive command are mentioned in this slides for reference, and we will do the required demo for running these two commands afternoon. This is about how to configure Wireshark. Although these are the steps written in this slide, but we will show you in live sessions each one by one. So as understood from this, it can decode to help you messages across the NR interface and various kind of things you can analyze going from RLC layers onward on various kind of interfaces, like include MAC. This is RLC, which you can capture at the RLC layer. And this is PDCP-NR. I mean, all these layers are on air interfaces. So this is how you can cover. Steps to log analysis. You need to open this Wireshark in MEC server, run these two configurations, and you are there to start. This is an example how to set up the respective filters and then check for desired message. Within message, you can go to the level of item, information item. So it's a very powerful. You need to select appropriate filters, appropriate protocols, and then regressively you can drill down or you can drill up. Example here shown log of GTP protocols. So I move on quickly to the agenda of chapter 9 end to end. Again, this will be done hands-on. Let me start. We will do all the procedure from the instance when UE is powered on. So first of all, once it is powered on, what are the steps going within UE? Although we don't notice, but if we start noticing, following are the important steps which UE goes. The very first is on power on, it initiate the cell search. I mean, it look around and measure the signal on all the possible cell around, and depending upon that, it decode the message, the respective message of the desired node. After obtaining the MIB, which is called master identity, then it can decode the cells parameter. And second step, it goes to system information block on downlink, and then typically captures the required parameters in order to do the cell search and decode the subsequent message. And this is the uplink part. Once UE power on and achieved minimum downlink synchronization, then it goes to second important synchronization called uplink synchronization. For this, there is a dedicated physical channels called RACH or PRACH. It sends random message, and then you network in GNB, it identify and response back. Once the access is authorized, then UE start requesting subsequent message to get registered itself in AMF, in core function. So this is how the process starts. And this is the ladder diagram which I will use to demonstrate various sequence UE goes through when it is powered on till the time sessions is concluded. So this pictorial representations, discuss from power on. The very first step is getting the master information block from GNV. Okay, and then step 2, get additional system information using various SIV. This much is mandatory. Then only UE can do the second step, which is called uplink synchronization, which happens on another channel called RACH, dedicated channel. The other two steps happen on a broadcast channel. GNV do broadcasting, and specific UE listen to them, and they do this. Okay. After uplink and downlink synchronization obtained, then it does registrations with the network. Then what you call AMF is come into picture. Before that, RRC radio at radio level, the connection is set up. Okay, which is as part of message 2, the request is sent from GNB, and then RRC setup request message 3 goes back from UE, and then RRC setup message 4 give required sufficient resources so that UE is ready for the next step. Up to this message 4, everything is happening at the RRC level and node involved with GNB. So far, no communication between UE and AMF or core. This is the first message. Now UE is equipped. Now UE send along with the setup complete NAS registration. So this is called piggyback message. Though two messages are combined, along with this setup complete, NAS registration is also done, and these are done on SRVs. SRVs stand for radio bearer, signaling radio bearer. Okay, and this message being transparently forwarded by GNV to AMF on the interface called N2. The protocol is NGAP, and the name of message is called initial UE message plus registration. So these two messages are combined, and this message is being forwarded to AMF in the core. The very first action in 5G is identity request. Immediately, AMF asks for identity of the UE. The next couple of messages you will see, NAS identity response from UE goes, and then again AMF decide, and if identity is valid, then it go for the next message, which is called authentication, right? Then authentication request is sent to the UE. UE sends response, and AMF, along with its multiple node, which is hide inside AMF, although not discussed in this graphics, but they are very much involved. Like AMF will send this request to AUSF, AUSF in turn will send to UDM, UDM will send access vector, and those will come back to AUSF, and then AUSF forward back to UE. So this, in happening long step, okay. And then once this is successful, user and network both have identified each other. Now time to get ready for user part. In user part, what is happening? We first of all do security mode commands. I mean, security mode means we want to make our channels and this security proof. So another send of two message like mode command and the response. These two encryption is enabled. So afterwards, all the communication between UE and the network will be fully encrypted and very safe. Later on, depending upon whether UE is coming first time or it's changing some context, then UE capability is being asked from the UE on once the command is given, and once the capability matches as per the profile as well as the capability of the UE, then these are being used in allocating the further resources to the user plane. Now, once this is being exchanged, proper match is established between core and the UE. Stage is now set to start with session establishment. So far, all these communication were happening on signalizing resource 0 and 1. Now we are starting negotiation for establishing this session. So for this purpose, context setup message is being exchanged. Once this is complete, then the previous sessions establishment request is being sent by UE, received by AMF, and in turn, although not demonstrated in this graphics, but in turn they goes to SMS, check with UDM and PCF whether the required sessions parameter are as per the policy in the network. And once all these internal procedures are completed successfully, then session is established and user traffic starts flowing in the between the network and UE. Till the sessions are continuing, the user plane make sure desired resources are allocated and sessions is continued with the required quality of parameters. Once the sessions is been successfully over, then radio resources as well as the core resources are need to be or must be returned back, and those processes will start. So these are the things this I explained you already. These are these slides just explain the exactly same thing which I told you. So I'm just skipping. This is already I discussed in my this PPT. Here are the some of the procedure captured in our tools, WireShark using NGAP as a filter, will demonstrate you this in hands-on. So right now I'm just, browsing through what is going to happen in the hands-on procedure. This is a part of picture of the slides only to make sure the very first part of synchronization and the information is being captured on Wireshark and being just, for summary displayed in this reference. This is again, getting SIB and MIB further detailing out. Now next part is being detailing out the registration process happening between UE and AMF. Okay. Again, there is a screen.
Due to network issues, the connection has been lost. Give us.
Hello, Ashish sir?
Yeah, able to hear you now.
Yes, yes. Is the screen visible? Please confirm.
Yes, it's visible.
Yes, yes.
Yes, okay. Thank you,
Okay.
sir.
Sorry for the interruption. I was explaining you the various procedure in 5G which happens. So I was explaining as part of sequences, these two identity, uh, establishing the identity between UE and the core network. So request is being sent and response is established between AMF and the UE. We have capturing some of the critical item through Wireshark, and this slides just indicate few of them. Okay, and we will show you the message by detail, element by detail in the demo. And this is the just response. Now, after identity is established, we move on to the security mode, which allow UE and AMF, including GNB, to establish the secured mode of communication. That means exchange the encryption keys between core and UE, and to start here onward the fully ciphered channels. No more plain text. So 5G network in that way is a very unique and powerful uh, system, taking care of security at the very highest level. Okay, this is the message. Make sure end to end every node is ready to encrypt. Then, as I told, 5G network handles variety of UE, and it is impossible to encode or configure all kind of UE into any possible network node. So henceforth, uh, a loosely coupled protocol has been designed where any UE and any network can exchange their capability on runtime. So no need to store all possible configurations of UE capability. So that's a very advanced capability in 5G networks. So UE on runtime can negotiate and tell the network, I have so much of capacity, provided the core network is properly configured with respect to negotiated capability in terms of subscribers, services, and UE capability. Both are met. Then core network, authorize all the required method come handy to enable UE to achieve this goal. And core network at the same time, core network allocate the desired, quality of service, including any slice if appropriate. So that's the things happening at this stage of communication and message flow. After this registration, accept is a message, indicating all the things so far has been successful, and GNB tell to UE in this last message all security related stuff and authentication requests are successfully completed. Now both the entity UE and core, including GNB, can move on to the next step, which is we can see is the establishment of data session. So data session establish request can be initiated by both the side. In this particular flow, we are showing a situation where UE is requesting for a session from the core, but it can be always the reverse as well, where the network need to establish session, have a session. So again, request moves through GNB. GNB transparently handed over to AMF. AMF will also seamlessly forward it to SMS, which is the anchor network function which typically manage the sessions. Okay. So here is the request, initial message request, produce resource setup request, and I will discuss in detail in the demo. This goes the response. You can always see a very, consistent pattern, request and response between UE and network. So it happened for all major steps, whether registration, whether capability exchange, or even same for session setup. So it's just a summary. I'm just skipping on. We already discussed this. This already covered. Okay, this is let me just summarize what are the various kind of radio bearers we have used. Typically, there are major two class of radio bearer. Radio bearer is nothing but a channel at a higher level, like at not the physical layer, even on top of radio layers. So these are higher level, channels, and they are called bearer. So this terminology at RRC and NAS level. Okay, not at the MAC or RLC layer, which we discussed in the forenoon. Now everything we are talking about RRC and NAS level. So data radio bearer called DRB, and again these have two kind of default, which provide always on connectivity with default, and if any UE required a special kind of, then it requests for dedicated bearer. And then in 5G capable device, there is a QS flow mapping from one or QS flow is mapped to one or more kind of DRBs for efficient data handling. Then we have a bandwidth modification required from time to time, depending upon the UE and sessions requirement. So this is not a static call flow or a static quality of service. It's a dynamic based upon the sessions stage and users' behavior and network condition. These are always optimized. Okay. Once everything is achieved, then all bearers are released before PDU sessions is logically concluded or terminated because of abnormal conditions in the network. So this is must to release the various releases inside the core network. Okay. And queue enforcement is achieved in 5G with the help of SMS and UPF. Right? UPF is actually anchor node to enforce SMS coordinates uh, between. So this is voice call and data call connection.
Hello. Yeah,
From
Bhupender
the
sir.
yes.
Your voice is, hello. Your
Ji,
voice is cracking right now.
breaking. Just a minute. Give us a time.
Okay, okay.
Is now better, Ramesh ji?
Hello.
Is my voice better now?
Yes, yes, sir. Right now it's better.
Okay.
Sir
So
Bhupender sir, I have one. Is it audible, sir? This is Sanjeev Kumar
yeah,
from
yes.
BHP. See, sir,
Yes, sir.
like one observation, what I'm finding that I don't know, like other participants, we are like losing our interest. So if you are showing us with the experimentation hands-on, then it will be easy. You explain in between, but hands-on and explanation, then that will we will be able to catch more details what you are explaining. You are taking so much
Maybe.
effort, so much
Yeah.
effort,
Okay. Give me 2
and
minutes. I will immediately. I will start my team after this.
yeah.
We'll move on to the. But just let me just wind up.
So
One or
fine,
more slide,
fine,
and
fine.
then we move on to the hands-on. Right.
Fine, fine, sir. Sir, one question also, you had highlighted bearer. So this bearer workflow is only between user equipment and G Node B, or this bearer will be also applicable for G Node B to core or core to MEC also?
Actually, this is between core and UE.
Sir, you are not audible.
I'm. Can you hear me now or no?
Not audible,
Hello.
sir. Huh, sir.
Just give us few seconds.
Okay, sir.
Hello. Is it clear now, sir?
Yeah, your
Yes, sir.
voice is more clear, Mr. Dax.
Okay, sir. Yes, I guess it is good also.
Okay. So I was just explaining your question regarding the bearer, right?
Correct, correct.
So
So I ask,
bearer
like
level.
bearer is required wherever the communications are happening between each entity, user equipment to G Node B, or G Node B to core, or even MEC also, or only it is applicable for between G Node B and user equipment.
And it is between GNB, core, and UE. But directly it is managed between core and UE, and GNB is, you can say, transparently giving the required resources.
Your voice is, sir, breaking somewhat. I think for me it is your voice is breaking. I don't know, like about other participants.
Let me try if Dax can repeat what I said to you.
Yes, sir. So which topic? This different bearers workflow? हेलो
हेलो। हाँ दक्ष जी बोलिए।
am I audible, sir? Yes,
Yeah,
sir.
you are
I
audible,
will be
but
talking
somehow
about this
it is
case.
breaking. Somewhat breaking.
Again, anyone other can please confirm? Is it same for everyone, or the Sanjeev sir is having this problem?
Yeah, everywhere we see that why is this breaking?
Give me a minute then. Hello, is it clear now, sir?
Yeah, better, better. Yeah, please go ahead.
Yes. Okay. Okay. Thank you, sir. So we were explaining this different bearers workflow, sir.
Yeah, fine. So
So
bearer is is different from like yeah. First thing is that where it is required, all the places it is required, or and in which case is more significant.
So basically, sir, it handles all the data and signaling bearers or different cores and other bearers modifications as well. And it is between G0B and core and between core and UE. And G0B acts as transparent between transfer this message.
Okay, bearer is somewhat different from packets, or what means?
Yeah, yeah. Actually, this concept of bearer is at the layers of not the lower layer. Like earlier discussions, we have discussed even logical channels. Those were at the lower level. Now we are talking about at the NAS level, NAS, which is run on top of radio network. Radio network are underlying network. These are the higher layers, and these layers operate only at UE and just currently pass and requirements are mapped.
Hello, Ramesh ji.
Hello.
Yes, Ramesh ji, we are having 10 minutes break, and after that we will connect.
Okay. Microphone.
This presentation. I'm taking over for this further analysis from Wireshark and Sigma ML, and I will also demonstrate end-to-end network testing with UEs. So currently, we are starting this chapter 8. First, we have to know how to configure Wireshark so that we can see all the required messages as per this standard. So first step is basically to download recent version of Wireshark, and steps are basically mentioned in the slide. I will also go through them so you do not have to hustle. So first steps is to basically go into this edit and then preference. So I have also opened a Wireshark for your reference. We have to click on this edit and then preferences. And under preferences, we have to go to protocols. And under protocol, first is we are configuring MAC NR properties. Just a minute. MAC NR. In MAC NR, we have to first select this attempt to decode BCCH, PCCH, and CCCH data using NR RRC dissectors. Basically, it will filter all the different logs based on these channels. And then we have to select attempt to dissect LCID. These are basically logical channel IDs 1, 2, 3 as an SRB 1, 2, 3. SRB is basically signal radio bearers. And for source and logical channel IDs, we also have to change few DRB channel settings, that is radio bearer settings, data radio bearer settings. And from that static table, we have to click on edit button. And then from LCID, we have to do this DRB mapping table as mentioned here. Now I will show in the Wireshark these settings also. I've opened this Wireshark. I have clicked on this edit, then protocols. Then in the protocols, we are first going on MAC NR. MAC NR, we are first checkboxing this first option, attempt to decode BCCH, PCCH, and CCH data using NR RRC dissector as mentioned in that slide. Second option is this. Third option is this DRB channel setting from static. Then DRB mapping tables, we just have to click on this edit and add these entries by just creating new entry and then add these fields mentioned in the PPT. Just click OK. The next field we are configuring is RLCNR. R on the canal and type R on the keyboard. You will jump into it directly.
Dux, your voice is cracking.
Yes.
Hello.
Who is also connected. Let me show you that as well. Just give me a second. I'm using Visor application for screening of my phone to this device. Just a minute.
Mr. Dax,
Yes, sir.
like,
Yes, sir.
see, these thing you have explained in the UAT also, but what I will follow, I will request like at least guide us to do this ourselves only, right? So that otherwise, what will happen? You will explain, and I think from my side, like I will forget everything. So if you are explaining step by step, then that will be easy. And if it is done for one or two cases, then rest of the things we can do ourselves also. By then, your explanation will be sufficient.
Sir,
Are you getting my
yes,
point?
yes. I understood your
Yeah.
concern, sir.
So
But
otherwise,
the
what will
problem is,
happen? Yeah.
like we have completed this UAT for almost all the institutes, for like 25 institutes currently. And
Correct.
we are explaining this training workshop online. So in first half, we have covered all the theory part. Now we are demonstrating our system capability, different set of procedures like how to connect UE, how to configure Wireshark, how to connect UEs with the radio network, how to configure radio network. Everything is well explained in this presentation. And we have also provided this presentation to every college so that they can also follow these set of commands and experiment on their own. And we are there to help in that case
Yeah,
if
fine,
anything
fine.
goes wrong.
That is
And
fine. That is fine.
moreover, when this hands-on part is required, in that case we can do one thing: just write an email on support or to me or to Prakash sir, anyone. We will take care for particular
See, that is
session
fine.
for
But
particular
your
college as well.
hands-on is over,
We-
not over, na? Your hands-on is still going on. So what I'm
Sir,
telling, like
our
at least
hands-on is not going on. It is a demonstration exercise. We cannot take every institute remotely 25 at a time and ask them to operate on their own while we are handling from remotely. In
at
that
least
case, if
at least what I'm
if
telling.
Sir,
that
for your college, if hands-on experiment is required, we can schedule separate call for that, in which you and me, we will sit, and I will guide you. You can do activity on your own,
that is
because
welcome. That is
it's a
welcome. But what I'm telling,
we
like,
can
if
do
you are
that,
telling,
but currently we cannot do for every college at a once. Am I clear, sir?
see, you are already handling the nearly 40 participants, right? So what I'm telling, like, at least if you are will be little bit slowed for initial commands, then what will happen? It will, like, most of the participants from the different institutions, they will understand and quickly, and then they will be able to do. So in that case, you may not need to do this individual activity with the each and every colleges if they require, right? So that is my request. If like it's okay for you, I can ask like separate help. But since you are
Okay, sir.
explaining
From now
only,
onwards, yes, sir. From now onwards, I will go very slowly. I will ask every question.
since you have
I will.
started, like I'm telling Mr. Daksh, what I'm telling you have just started, and if you will tell so many things in a hurried manner, then what will happen? The similar things we will do in and again, and we will miss the link, right? So if you will take care in initially, right, later on it will be easy for all of us. We can do it faster
Okay,
also.
sir.
Even if you're doing is fast,
Understood.
that doesn't matter, right?
Understood, sir. Understood, sir. Okay, sir. Let me continue with the exercise. In case, sir, we can also ask TCIL and DOT to provide this session recording to every college, so that it will be much helpful for every college to understand these things at better level.
Yeah, that is
We
fine.
can do that as well. Yes, sir.
But at least one session or of 10 minutes or 15 minutes, that should be comparatively slower, even if it will be recorded. So if anyone is watching later on, they can
So
understand easily, right?
I,
That
I,
I'm
I got your point, sir. I got your point. Sir, our agenda is that designed in same fashion. Today we will cover this and theory part and all the end-to-end verification part. Once this is finished, then the whole another day, which is 27 days, lined up for activities like hands-on different devices like evaluation board, drone, where you can also parallelly use your lab's device to connect in the same fashion like we are doing this online, and we can match up on that pace, right, sir? So this is already designed in this fashion only.
okay.
We are
Okay,
trying to cover that part as well.
okay, fine.
Okay, let me continue, sir. So this theory is already covered. Let me go to this verification part. These are different G0B logs where I am taking one frame slots log where I will explain different entities. Like first, these are basically different RX, PPS, kbps, different values, and these are for TX, PPS, kbps. These are basically hardware level logs. Then we are having MAC level logs, where for every slot we are getting different messages. This is a RNTI. RNTI E031 is for this UE currently, which is being attached to this network. Only single UE is connected currently. And this RNTI is uniquely identifying this UE which is connected to this network, and it is separate for each each UE. And this CUUE ID1 represents that this is a first UE which is connected to this network. In syncs represent that it is in synchronized with network. These are different values like RSRP, reference signal receive power, that is minus 89 dBm, which is considered to be more than good. In next line, we are having CQI, channel quality indicator, which is 15, which is again very good. It lies between 1 to 15, and we are receiving 15. RI is number of layers, which represents 2 here, and which means we are running this our radio unit in 2 cross 2 mode. And next is DLSCH, downlink scheduler, ULSCH, uplink scheduler rounds. It also represents different errors, different thresholds, and blocking error rate on DL and UL level also. It also helps us in understanding different MCS values. MCS is modulation coding scheme. So basically, our modulation coding scheme switch switches dynamically, and whenever more throughput is required, it sustains into that fashion. In next line, apart from this blur and MCS, we have SNR, signal to noise ratio, and after that we are having different logical channel IDs packet transfer data. Logical channel ID 1, logical channel ID 2, logical channel ID 4, and these RX TX represents different bytes transferred between these. So currently these are runtime logs which I am showing you in our lab, and this is a UE which is currently connected to this network. We can also verify by going into settings. You just have to navigate to settings, then mobile network, then SIM1. Then you can check the operator name as India 5G Lab. This is our own private 5G network. Once this is verified, you can also navigate to Sigma ML application. This is an application which helps us in understanding different logs at UE level. So once navigated to this screen, click on these three dots on the top right section and start measurement. Once it is prepared for measurement, so we can see different informations like ARFCN frequency. Just a minute. It is in airplane mode now. The session is released. We can see at the background the runtime logs are empty now. If I'm toggling between airplane mode, now the session is established. Now we can see the logs are also running. Just a minute. Yes. So we are providing NR. So in NR, we can check this is a band information like N78 band, which we have provided. This is a center frequency 6407 ARFCN, absolute radio frequency channel number. On the second, we can see ARFCN, absolute radio frequency channel number, which is 640704. If we convert this absolute radio frequency channel number into frequency, so it will come around 3.61 gigahertz. Next is NR frequency. It is again 3610.56 megahertz. Next is NRDL bandwidth. It is 100 megahertz. After that, we can check RSRP at UE level also. It is minus 91.8 dBm. And apart from this, on the bottom side, there are different options. First is test details. Second is airplane. Third is cell. If you click on this cell, you can see RSRP chart here. And on next side, we have different charts available, which include different sections which we can see. And after that, we have to navigate to this 5G NR. In 5G NR, we can see different field values like serving cell info, measurement info, beam measurements, SRCH info, PUSCH info, CSI info, PMI info, uplink downlink info, modulation rates. All these things are available at UE level also. If we want to check same at G node instead of G node B, we can check same logs at AMF also. So these are runtime logs of AMF. Currently, we can check from this screen that one G node B is connected with global ID 0xe000 named W4S G node B, including PLMN, which is 00101. And we can also see different UE's status, like one is deregistered and one is registered. So currently the phone which is connected on my visor is connected. We can see here as well. We can also confirm UE's connection setup, its registration, deregistration from AMF logs as well, and monitor that here. So I have switched my device into airplane mode. We have seen that the release request has been sent. We can see that the release message release is complete, which is sent it to AMF. Now I am again toggling its airplane mode. We can see the background that PDU session resource setup response is done. It means UE is successfully connected with the private 5G network. We have covered Wireshark, Sigma ML currently, including end-to-end verification between G0B, core, and a UE. Any doubts so far? Any doubts, anyone?
Acha, Dakshi, tell me one thing. Hello, is it audible?
Yes, sir, you are.
I'm telling like once your whole system is on already,
Yes, sir.
so and if your user equipment is if you are making it in flight mode, but it should come like by default it should be connected as a user, but normally it is not coming. What is the reason in that case?
Sir, there are different scenarios for this. First we have to check our connections between G0B and core at the basic level. Once our G0B and core are successfully connected, then we have to check whether our radio network is radiating, whether the RU is radiating or not. If that is also radiating and everything is good, then at the last and the third step, we have to check at a UE level whether the NR only mode in the UE which we have supplied is enabled or not. If not, then we have to configure that. Apart from API 5G switch NR only mode, we also have to cross check our APN NR UE, which is provided by W4S. Once these all settings are connected, cross-checked successfully, then it should connect, sir.
But most of the times what happen, like if your system is not off, then it may be the problem. But if your system is already working, it should by default it should be connected. The moment the user equipment is on, like it should be connected. But this problem is
So,
happening.
okay,
Means
let me take care of this part, sir.
have you discussed anywhere in like in the PPT there? So those steps are also mentioned.
So basically, this is from training presentation, and we are also providing one training manual, including use case lab manual, solution manual, implementation manual. And so all the steps are mentioned in those documents for
Okay.
debugging purpose. For
Okay, so it is
debugging
not
purpose
current.
mainly.
So currently, if you are making it on, so all these steps have you mentioned in this slide?
Yes,
What you are
yes,
showing
yes,
is
yes,
mentioned.
yes, yes,
Okay.
yes, sir.
Okay.
These steps are mentioned in the user manual, and
Mm-hmm.
moreover, there are two cases. When we power on the server, so there are two things. First, the hardware is on. If you have just switched on the server, it means your hardware is on. Once that hardware is on, you also have to run few applications or services on that server to make that active. If both things are up and running, then UE should connect.
Okay, fine. Okay, so
Yes, sir.
like in two steps, you had shown the ML Sigma software, as well as before that you
Wireshark.
had before Wireshark, like in the user equipment only. So where you need to enable the systems in mobile network only.
Just a
Can
minute.
you
Let
tell?
me
Can
help
you tell?
with this. Let me help
Yeah,
with this UE.
yeah,
So,
yeah.
so currently it is connected, sir, because it is being configured properly. First, we have to check this APN settings. Go. Let me open it again. Let me know if I'm going very fast. Open settings, sir.
Settings.
Am I clear?
Okay,
Mobile
okay.
network.
Mm-hmm.
SIM. First,
SIM.
we have to
Okay,
check
okay. Fine,
SIM,
fine.
and then this APN. So this is the
Oh,
APN information which must be present in every UE to get connect to this network.
okay,
These details are already provided in the user manual. Once
okay,
this APN is successfully configured, just save it and apply it. Once it is enabled, this is an application 5G switch. Okay, sir.
Mm-hmm.
This
Yeah,
application 5G switch. Once this is opened, you have to check this set preferred network type is on NR only. It should be on NR only. Otherwise, this UE is not gonna work.
okay.
Generally, on the default mode, it comes on this NR, LTE, GSM, WCDMA, this option. So we have to switch from this option to NR only. And once it is selected on NR only, then we can say that our UE is successfully configured. G0B is on prerequisite. G0B and core are already configured. This UE is also configured. Now it will connect.
Okay. So
There must be some settings
5G switch,
missing.
in
Yes, sir.
5G switch, you have to go for where? Where you have to go? A network
Sir,
setting.
this no, not network setting. This set net preferred network type option. Is it visible on my screen? Set net preferred network type.
Uh,
This option, sir. If
yeah, like
required,
you
you
had gone
can
for.
open the UE
Oh,
present in your lab and just go to 5G switch.
yeah, I had gone for 5G switch. That's fine. Then
Yes, sir.
I'm
And
finding like
just
network
scroll.
settings. That's all.
No, not
Network.
network settings. No, not network settings, sir.
Okay, might be some issues might be there. Okay, fine. Like we can like take help from later on, right? Because it is
Yeah,
showing only
yeah.
5G switch uses network setting. That's all.
No. You must be on a wrong position or wrong directory. Just see my screen, sir, if you are able to see. I'm guiding on you with the UE only.
Yeah, I also opened the network switch, but in
No,
network
not
switch it is
network switch, sir. You have to open this application, sir. Just check my screen once,
5G switch.
please.
Yeah, fine.
This 5G switch application. And are you able to see the cursor?
Yeah, I'm able to see the cursor, but these options are
Can you
not
check?
showing.
Can you
That's
check
why.
the settings? Set preferred network type.
See, Mr. Daksh, I'm telling like the moment I'm going for 5G switch, it is showing only uses network setting. That's all, nothing else. That's why.
Sir, I will connect you personally to resolve this
Fine,
today only. Just give me some time.
it's fine.
So
Now you can go ahead.
I was yes, sir. So we are done with Wireshark configuration, Wireshark capturing, Wireshark analysis, Sigma ML analysis, UE connectivity, G0B and core connectivity. Now we are proceeding with chapter 10 and 11 and 12. Over to you, Bhupender sir. Thank you, sir, for this chance to present me. You can use my phone for this.
Thank you. That's taking the team through a detailed hands-on, and even Dux has shown you multiple message flowing between UE over the interface, then uh, captured and analyzed with the help of Wireshark as well as Sigma ML device. So this must have given you some first-hand feeling. And as some of you pointed out, it's going too much of theory. I hope now you have some comfort level in the training with hands-on. Okay? Hello? Hello?
Yeah, Bhupinder sir, you are correct. You are correct. But like the complete theory sometimes bore the
Yeah, I
audience,
know, I know.
especially,
Professor, I
especially,
can understand
especially
your
teachers.
concern. I can understand your concern. So that's the reason I'm expecting my respected professors to, intervene me whenever you are flowing, things are going little, monotonous, or you need more hands-on. Please interrupt as we move along, right?
Correct,
So,
correct.
uh, if I summarize so far from the morning, we understood various underlying concepts regarding the main 5G infra, which is mainly core network, radio network, and many protocols, binding them end to end with the help of UE. And to enable this understanding, it is very essential to little bit be comfortable with certain tools. In our case, these are wireless or Sigma ML, as well as some log analysis of various our applications running on core and GNV. So Dux has spent some time. I understand, Professor, we cannot be very, eh, expert. It will take little time, and I am very sure with the help of our team and your team, we can, very soon graduate to very comfortable state managing your labs in day to day. So that is my objective of this training, and I expect a lot of feedback, constructive feedback from each of you to make this training really useful. And the objective is this training is to make you use this lab effectively, develop your use case. That's the end goal. So with that objective, now I want to take you to another topic of the day, and this topic is little bit giving another context how AI, ML, and IoT is the focus of 5G lab use case, right? So because a lot of analytics which are being deployed as part of MEC server, they have some element of AI, ML built into it, and they in turn they are not compute intensive end devices. They are IoT. Mainly, most of the IoT are constrained by endpoint compute, and henceforth we need to use a split architecture in most of the situation where some part of pre-processing are done at the end devices. Then some of the analytics are, done at MEC server. That's what is a hybrid approach of AI/ML. So with that intent in mind, I will move on to this chapter. Uh, and again, I want to tell you this is not the end. This is the start. AI, ML, and IoT both are so evolved domain and topic. It will be insufficient for me to give any real justification in given this time. So I need apology for that. But let me start with the topic. Okay. So I will cover overview of AI ML techniques at the very, very highest level, and then list some of the area in 5G where AI/ML can play a significant role. Then the second topic related to our use case lab is IoT devices, which we are integrating. So we talk about some, again, overview kind of the technology involved IoT, and obviously what are the various use case and deployment scenario which are applicable to our lab solutions. And in the end, let's see if there's some standardization in 3G IPP is applicable for our solutions. So this will be a very short uh, discussion of this important topic. So let me straightforward jump to the very first term, AI/ML. and it's very, very superficial. Artificial intelligence is nothing but a simulation of human intelligence into the machine. When I say machine, into basically uh, compute. That means software programs, or sometimes it is a hybrid of software programs and some accelerator hardware meant to run the efficient AI algo. So then within that bigger context, ML is a subset of AI, basically, which enable system to learn from data. So key difference between first and second is this is a subset, and only this rely on data of the past as well as the present. While generic AI is, as you know, is even not only data, it's something non-data kind of things are also taken into account. So key ML techniques which are being used in our solutions, basically supervised learning technique, where supervised means the labeled data is available. That means correct answer as well as corresponding inputs are available to train the model. And a very first level of example which comes to my mind, a detection of spam mail. Okay. The second type of machine learning are unsupervised, where no easily available data is available in the data set, and it is trained itself. Algo or machine need to find out themselves what is the reasonable labels, detect them, and then use for subsequent inference and predictions. One very common situation which is done is customer segmentation, where depending upon the preference and user behavior, customers are segmented into different kinds. Okay, the third one is called reinforced learning. Basically, it falls in between and between supervised and unsupervised. And here, the motivation is the machine learn from the environment by way of trials and error. So no right answer, no left answer. They are left, they guess something and then take a feedback from the environment. Environment give the reward and the punishment depending upon if it is the right action, it's rewarded. If it is not the right action, then they give it the negative impact. And one very good example which come to mind is self-driving cars or UAV kind of stuff. Okay, other than these three classical learning algo, there's also recently been called deep learning. Basically, deep learning is very much motivated and influenced by the human brain working underlying concepts. So neural network, as all of you being aware, so natural intelligence in the brain is typically modeled using neural network, and our brain consists of billions of the neural network. The same motivation is being adopted in computing parlance, where artificial neural network is a basic computing unit which simulates at a basic level a very equivalent to neural network in brain. And as you know, brain is connected with billions of and millions of neuron in many different configurations. Same here, ANN being designed having multiple layers and node, right? So this concept is being also used in our some of the app, especially video analytics app fall under this category. And very sample example which will be demonstrating you facial recognition in case of our camera as well as drone. Okay, the last kind of learning is called federated learning. Basically here means as you understand, uh, in case of real time sensors data, we have to depend not only either a centralized or a endpoint. We deploy intermediate and immediate what you call computing resource. So federated learning plays a very important role. That means the overall learning is decomposed into multiple steps. So some of the learning part is done at the end, and at the what you call sensors or devices, front end devices, partly trained model at respective what you call endpoint. Sorry, not endpoint, the front end point. That model is then forwarded along with the this intermediate to the what you call intermediate node. That could be either cloud based, or for our application it could be MEC server. So federated learning actually decompose the learning problem into two places, and these models are internally trained at two places, or multi-step. This could be multi-step. So with this very top level understanding, I am not taking over much time into go to the extensive AI coverage. So let's see how these techniques can be, how they can be play a role in cellular network. So far the progress in 5G. In 5G, AI ML is not a technique which find its place in native. This have been afterthoughts in 5G. Henceforth, they are being not part of inbuilt layers at various places. These have been uh, targeted at management level, not in the user plane and control plane. So all these applications which I am discussing here, they limited to network, not user plane and control plane. They have been into management plane, and an example of management plane is self-organizing network, where AI-driven optimizations algo are run on a network parameters like optimization of power levels, frequency bands, and handovers. So all the data is being captured from the network, and at the central place, this data is being routed. Various models are being run with respect to the power optimization, spectrum uses, as well as the handovers optimizations. So these find applications, but uh, these are being exploited in many 5G public networks. And because we are going to discuss with private 5G, so this is not a good example. But okay, same goes with the predictive maintenance and fault detection in case of various network component in 5G. It could be many GNB nodes as well as the core and the end devices. So again, data related to faults and maintenance are being monitored with the help of ML models, and based upon past historical data as well as the current network conditions, the models can predict failure in advance, so that timely remedial actions can be planned, so that breakdown time can be minimized from the live network infrastructure. Okay, the third dimension comes with related to security and threat. AI powered again is utilized in 5G to analyze various intruders alarms, identify in real time as well as from the past history, and they help us to predict some of the based detections in case of security threats. Last but not least, it help us manage the network slicing and orchestration, which is architectural achievement in 5G and beyond. So edge in edge or in at the appropriate place in core to reduce the network latency and improve the final outcome of the applications which demand very high, very low latency. Similarly, 5G plays very high importance on QS, which we just discussing, earlier part of my discussions. And henceforth, in coming, what you call 6G, ML will find extensive uses in smart beam farming and MIMO antenna configurations for achieving the better coverage and high throughput and and achieving the best of QS within a given environment. Okay, and 5G with AI-enabled IoT and smart applications, it can be deployed in many IoT segments, including Industry 4.0, including in healthcare, doing the remote surgery, or could be in many more challenging environments. So this is, I can foresee the AI/ML applications as we uh, go along into this. So now I move on to the second part of
Sir,
discussion. Yeah,
Jitendra sir,
please. Ji.
sir, you like discuss the different AI ML techniques. So these techniques are implemented in this system what you have provided currently. 3GPP 15 release you had installed, right? Or 16?
Yeah, so although my presentation is too much, broad, but let me quickly narrow down to the thing which we have AI/ML component which I have deployed. In case of camera analytics, which MEC that use that analytic use some component of AI/ML model.
Okay, okay,
Okay, so that is
okay,
the answer. But my talk is very broad and forward looking. Okay,
okay.
I
So
am
it
giving the
is
direction.
correct. So it is not
Okay.
related to 3GPP 16. I mean, currently all the setup has been developed based on the 3GPP 15 or 16.
This
Is it
base model which is given to you is 15, but
15
our
only?
roadmap within a certain time frame will cover release 16 as well.
16 also. Like so,
Right.
these AI models are also included in the release 14 also, 15 also. Okay,
Yeah, limited
understood.
to a limited sense. Like camera analytics is a one component which is hosted on MEC server, which have inbuilt AI ML modeling.
Or
especially
similarly,
especially for especially for object detection, face detection,
correct.
people counting, all these analytics which is being hosted, they are very much using AI ML technique.
Similar features are
Interesting.
in drone also, sir.
Yes,
Similar
yes,
features,
Yes, you're right. Yeah,
yes,
yeah.
yes, sir,
yeah,
correct.
face
Drone
detection,
also.
human detections are also like with
Yeah,
the drone camera also. Okay,
yeah, you are, sir. Bilkul. You rightly got the point. And
okay,
but still these are starting of AI ML.
correct.
Right. As we move on into the forward-looking next release, as well as as we move to 6G, this AI ML move into the every aspects of network. Currently, these are into very isolated place in the user plane and as well as. But if we move into 6G and coming, AI ML will be into every part of every layer, control layer, whether it's a cellular, whether it's a QS flow, everywhere AI will be natively placed.
Okay, sir. Sir,
Okay, so
in your roadmap, like what are the other video analytics or related to this AI ML you are going to provide us?
Let me answer. Sir, from this UAT point of view, we have supplied sufficient analytics and applications for this lab. And for future development, we can support if required based on different use cases if any application development or anything is required. But in roadmap, only features of G0B core and MEC are pending. No application point of view test case is in roadmap. From
Oh,
application and devices, from that aspect, everything is completed. But in case of a few features from G0B core and MEC, only those things are remaining,
remaining.
and those are
Okay,
part of next release.
okay, fine,
so as Dax has
fine, good.
clarified, so we will see what features are as per roadmap. But obviously, AI/ML is not the focus. Okay. So with that understanding, we will moving to the next topic. We will again briefly describe the IoT technology. IoT refers to kind of physical devices which are connected via internet. It's not just a pure software smartphone. They are physical objects and they enabling data exchange using connectivity. So these devices include sensors, smart appliances. It could be wearables, health devices, and industrial machines. So key characteristic quickly, they need a connectivity. Uh, it could be Wi-Fi, Bluetooth, or 5G, including low power WAN. Then they have sensors and actuators depending upon kind of domain we are looking at it. Then compute can be either at the cloud or at the edge, depending upon what kind of application we are planning. And then analytics and AI softwares. So these are the 5 component in IoT. A last component is the merger of AI ML with IoT, right? So, okay, so let's see what could be the combination possible. The common IoT applications, although this list is not any means to show you the exhaustive list, we put some very popular case. Home is starting with smart home, which could be home automation with connected devices. Then it could be industrial IoT, which can help maintaining health of the assets in the factory. Healthcare, wearable health tracking, as well as telemedicine, and obviously, least not the least, telesurgery, which is a very safety critical application. Similarly, smart traffic, we can manage traffic and environmental monitoring of the smart city, connected devices and V2X communications, and smart agriculture. Okay, so let's see the last part of this. What are the various for IoT and 5G integration? Again, we have listed at a very, very top level these specifications like core and service architecture for IoT is explained with system architecture in the specification and for video and obviously last this. So I recommend you to all the students if they want to do more these documents, we can also consume some of them when we. Okay, these are some more related to protocols and optimization. And one of the very common IoT platform is one M2M. I don't know whether how many of organizations you are familiar with. This is one of the very open M2M platform. Then obviously we have 5G optimized for URLCC for IoT applications. And in addition to that, 5G positioning and location service is described with this service 305. Broadcast and multicast is again a latest add-on which IoT can be used. So with this, I able to rush, not say like about
Upinder
detail,
sir,
but I touch this
hello.
something. And
Yes, Ramesh ji.
Your voice is cracking, sir.
Sorry.
Your voice is cracking.
Again?
Now it's better.
Okay, just a minute. Start, sir.
so I am now moving to the next chapter.
Ramesh ji, please confirm the voice level.
Ramesh ji, is it better?
Yes, yes, sir. Right now it's better.
Okay. The next topic is related to security features in 5G and its building block like core, RAN, and devices. And it
Sir,
will
Bhupender sir,
be.
sir, one question based on like what you had shown for technical specification. So, what is included? If you will highlight like which technical specification is included and given in different labs, sir? These you had shown certain specification, 3GPP
Ye-
technical specification for IoT, right? So
ye-
these IoTs are just like for helping us to implement, or like you had implemented in our system as well.
You know,
So,
it's a general specification which we have, compiled in this slide, which
Okay,
can, become a reference point for us or all the sheet to work for future, right? And
correct.
obviously,
So
our
in
solution is also inspired by this, right? But
correct.
this
So
is not the
which specification has been included, sir? Means out of 23501 or 300 or 33501. So any
uh,
features has been included in our system or our the
obviously.
setup you had provided.
sir, what specs we are referring to?
So like as Bhupender sir has highlighted in the
Yeah,
like
yeah.
slide
I will
23 and
just tell
24,
you. Yeah.
right?
Yes, sir,
So
224.
You
different
can see.
technical specifications regarding IoT and integration he discussed, right? So I'm asking like what are the specification has been included in our systems? Any specific system or like not any particular specific included in this the products you had provided us?
So basically, sir, these specifications are based on different system architectures, overall descriptions, and security architecture and procedures for 5G.
All are
These are covers
compulsory.
in
Yeah. Mhm.
yes. These are key 3GPP technical specifications in regarding in respect with IoT integration, with which comes in different release. As soon as we will upgrade our releases, these features with time to time will automatically get add on with the releases in the
So
3GPP.
that's the like these specifications are under which release? 3GPP was which release?
I will confirm that and tell you, sir.
Okay, so just confirm us also like these releases are like under which and in your developed setup, which specification has been already included and taken care.
Okay.
Okay.
Yes,
So
We'll map it to the our features. Okay.
yes,
fine,
yes.
fine,
Our
fine.
features and solutions.
And that will
And
definitely help us to like if you are developing any IoT based on if those features, so
Mhm.
that will guide us to do that, right?
Yeah, sure. We'll map it down to our
Yes, sir. Our
solutions.
system mostly supports all the release 15 features and partial release 16 also. And I guess Vikas sir or Ashish sir all must have shared the undertaking for the same as well.
So right now, I don't have ready-made answer of how many,
Fine, fine,
you
fine,
know,
fine.
compliance of this, but we will definitely work out this answer and come back
Uh,
to you on this
yeah,
part.
it seems like most of the things may be there, but like
Yeah,
if
yeah,
you are confirming us, then it will be easy, right? Good.
Yeah,
yeah,
we
sure,
will
sure.
do that. No worries.
We'll do it.
Please,
We'll do
please
it.
proceed,
So
sir.
let me proceed to the, other agenda of the day, which is related to a security aspects and quality of service. Yeah, these two things are I'm going to discuss. Again, my coverage is very overview, right? And this is not exhaustive. And let's see how much we can do given a constrained time. So quality of service basically is nothing but set of parameters which provide a, a defined service experience for a given class of user and service. Parameters typically are throughput, latency, error rates, jitters. These are the parameters which define a quality of service. And now 5G have put very special focus. And the key concept on 5G is called QS flow, which is a unique. This was not there in earlier generations. And this provides us a more finer granularity control in quality of service in PDU sessions. So each PDU flow is in 5G is identified by a QFI, right? And this is unique within a given PDU sessions. Okay. And this is obviously improvement over the previous generations. 5G provides multiple QS flow can be mapped to same DRB. In earlier case, it used to be 101. Okay, QD session can transfer more than one QoS map to a DRV depending upon the nature of applications. All packets belonging to same QD sessions with the same are prioritized equally in our network traffic while it is being handled by the UPF. The UPF work on this understanding. The quality typical category of QoS is three kind. One is called guaranteed bit rate, in which case n of resources is guaranteed by core network so that can be achieved. Then non-guaranteed means some application which do not need will be this. Delay critical, which is called URLCC in our case, for which priority resources are allocated to this. Okay. So 5G NR has introduced this as this dedicated protocol here has been SDAP is meant for this, and we already this protocol this handle DRB as well as SRVs, and this shows pictorial how this various kind of quality flows QFI map down to various QS channels. Okay, so as you can see, this is a user plane function, and I'm showing mainly a data radio bearers, which is main of the interest for our end-to-end applications. Although we have also called signaling radio bearers, but mainly our focus is here giving the user level. And again, technical specification for this is TS 37324, or we are very much compliant with this. Okay. The 5G network security architecture can be partitioned into multiple first of all, network access security, which protect UE access across the network. Then we have the network domain, various core function within themselves, how security is implemented. User domains means our various kind of UE, how they can be uh, protected against the theft and unauthorized access. Application domain means communication application which we are running external services, maybe beyond 5G core. And obviously, because our 5G is based upon service-based architecture, so this additional service architecture, when introduced the simplicity, reduce complexity, but at the same time, it creates a new threat vector. So how we achieve that? So that's the last part. So first of all, 5G key security feature is it included an additional feature called SUKI. SUKI stands for Subscription Concealed Identifier. Previous generation of network, there was no method to encrypt IMSI, and it was leading to IMSI catching threat scenario. In 5G, this has been addressed by applying a concept called subscriber identity is never been exposed on an interface without a encryption. And the other key is a unified authentication framework, and there are multiple frameworks suggested in 5G specification. Our solutions very much support 5G AK, which is the most prevalent and secure methods. Although there are two more, but our solutions is compliant to this much. Now, if we talk about the solutions for external actor records, so as you know, we have supplied along with you very powerful firewall solutions, which will take care of many external attack vectors, especially within the 5G private network. It is a firewall which can handle, various kind of traffic filtering at various level. It we will detail out once we go to the tomorrow to the detail, discussion on our firewall. But here I am listing top level. It helps you to detect and prevent threat directions. It allows you to achieve VPN secure remote access. It have a powerful filtering for filtering various web applications. You can block, you can enable in any website. It also provides DOS protection. So these are some of the things which we can provide. So what to do to this? We need to proactively monitor end-to-end threat intelligence, which is called intrusion prevention, and ensure threat intelligence are updated and appropriately virus signature and are captured, and the firewall should be automatically updated this time to time. So these are some of the good practices which we should use to achieve in our 5G setup. Infrastructure is equipped to monitor proactive security. Institutes, and with the help of us, we should always keep our firewall updated and configured correctly to achieve this goal. And we can do advanced web filtering. We can block many sites. We can define various policies. Okay. Similarly, we can decide which application to block and which known to us as a vulnerable and pose a security. We can also log extensively all the incident related to security violations and access violations, and then those can be reported, configured based upon the activity which we plan. Such real-time alert is good enough to suspect event such as unusual traffic, block attack, policy violations. We can always do this. And to make this more effective, we need to keep update all the latest patch known for vulnerability and improve. Because security is such a dynamic activity which every day pose new threats, and at the same time, every day comes new countermeasures. So it's very important to keep aware of all this and make our 5G security firewall to the latest available versions. So this is here what we can do: reporting of the alarm. Where we can enable the reports. We can enable the alert. We can choose or customize the frequency. We can even send email. So we can do this. I'm just this we will cover anyhow tomorrow. I'm not going to spend much of time. Huh?
क्या हो गया इसमें ज्वाइन नहीं है वहाँ पे आते नहीं है आप अपने फोन से ज्वाइन कर लो इसके फोन में तो कॉल्स आ रही है बार बार
इसका सर
लिंक आपने फोन में डाल रखा है नहीं डाल रखा लिंक नहीं है
Hello.
हाँ इसको क्लिक करिए
Is it?
हाँ
Hello.
ठीक है ओके
क्या है ना स्क्रीन में? बस वो नहीं हो, ये है ना,
आई थिंक
ये है, यहाँ गया।
These are some of the facilities which are available as part of our security solutions, which I was explaining, and we'll repeat it tomorrow once we go to this. So this was for network security. Last item of the day is NMS, and we'll quickly walk through what are the capability and give some hands-on which is available in our implementation. So basically, network provide the capability to resource management centrally from one place. So it can involve efficient allocation of CPU, memory, bandwidth, storage across all the nodes, whether it's a RAN or virtual network functions. So key feature which is part of our in case of network function, we can always dedicate certain CPUs. Okay.
Hello, am I audible? Hello,
Yes,
anyone
yes,
please tell?
yes,
Yes.
yes.
So our colleague Ritvik is taking next for NMS. He will be covering all the required details for this. Thank you, Bhupinder sir, for presentation.
Okay. The resource management feature is can be found on the NMS via going to the appropriate dashboard. Let me just open it up. Go to the dashboard tab and navigate to the resources dashboard. In that dashboard, you can see the CPU resources, the memory resources on the nodes, which are being allocated for all the processes running on there, as well as the memory being utilized by the system in terms of heap memory and the network bandwidth utilized in receive and send both directions. So all of these processes are in the background regarding DPDK, QoS, and power management being going on via the processor, whose status can be utilized, can be seen via that dashboard. For
Ritvik
all
which
the
dashboard you are talking about?
this ones,
1422. Okay, okay. So this dashboard is like including everything regarding 1422.
this is regarding the node level, the device level resources. 1422 is not the dashboard. Actually, this is an advanced dashboard that will be released to you in the next release. I'm just
Okay, okay.
presenting it
Currently
to
it is
you.
not available. Okay, okay, fine.
Yeah.
Okay,
So I'm just demonstrating you the next release dashboard features.
okay,
So
fine.
that one is the device level resource allocation that is being done on the servers, and in the container level resource allocation, you can see all the virtual network function resources that are being utilized by the network nodes. That is the UPF, the UDR, NSSF, SMF, UDM, all the network nodes. What the CPU utilization is currently, you can see. So any up and down in terms of CPU utilization is mostly seen in the UPF nodes and as the bandwidth increases and decreases. So that's and it is. नहीं मैं यूटिलाइज करूँ तो हिला रहा हूँ उसे okay for fault management you can navigate to one second Let me navigate to the log. Yes, here it is. For fault management, you can see whatever notifications are coming in your logs via whatever events that are occurring. For specifically, this event is an SMF node. So it is showing the UE has registered what the SOP of the UE that registered was, what is its IP address, and what's the SST and SD that it is registered with, along with the timestamp, the time of PDU session creation. This is. And let me move on to, so similarly, as you can see, the info level logs are coming here, and any debug and let's say error that occurs can be seen in this information also when that level of log occurs in that case. Rameshji, I had to rejoin the meeting. Can you share the link again? Oh, presentation rights to
Hello.
the,
Hello.
yes, hello.
To whom provide the access? Right?
Daksh, provide presentation right to Daksh again.
Okay, okay. Granted.
Okay, sir. Yeah. So I was in the performance management state. For performance management, you can analyze the all the metrics regarding CPU and bandwidth consumption by all the network nodes. I had already shown that to you, but let me show it again. So wait a second. Yes. Memory limits. Wait a second. Yes, these are the disk input outputs and read write memory limits. 1 second. Yeah, this is the network bandwidth. Going through all the network nodes, that is the CPU, MEC, core, and GNB. So all the system level network receive bandwidth and send bandwidth are present in this dashboard. These are the steps for using the NMS. I think I can show you. We will forward you the login steps, but I'll show you once. I'll have to sign it on. You have to put in the username and then password via which you can sign into this NMS, and we will create role-based access for you in which some specific dashboards will be present to people for observation features only, and some extra dashboards which have management features for executing the core and RAN. Those different login IDs will be shared with you for different types of access. So this is the configuration and execution dashboard. So in this, you can configure the MNC and the MCC and the tracking area code, SD, SST, and center frequency parameters in the network, and start and stop the core network as well as the G node B from this dashboard. This was part of configuration management only, what I just described. The MCC and all these values, you can change it up dynamically. And when you restart and when you start the node after changing the value, that value will be applied only then. That is the concern. Yeah, you have to restart the network after putting a dynamic value into it. Configuring Gnode B. So the MCC and MNC are the values which combine and form the PLM ID. So for the configuring of Gnode B, you can configure the PLM ID by configuring MCC and MNC only. And this is just some basic explanation for that. The MCC and MNC value combine and form the PLM ID, which would be applied via this dashboard to both the core and the Gnode B nodes, specifically the AMF, NSSF, and the Gnode B. Center frequency. So here you can configure the center frequency, which would be applied on the CUDU portion of a Gnode B. And for the RU configuration, you would have to configure it in the RU via the terminal only. That is not available via the NMS. So
those steps are available.
Those steps will be available in the user manual. Bandwidth. Again, bandwidth is something that has to be configured in the RU. And CUDU option will be provided when with the release only. An extra parameter would be here with which you can change the bandwidth also. Monitoring of 5G network. Okay, let's move on to. For monitoring, you can see all the network events that are occurring in every node. By this is the core management node. So in this node, you get the notification of attachment of any UE and its PDU session status. And in AMF node, you can monitor what is the status, whether the Gnode B is connected to the core network currently or not, and what devices are registered, whether it is deregistered and any issue has occurred or not via the AMF node, as well as any other nodes status can be seen through this dashboard via the logs of every node. I think that's it regarding the NMS section. And all the chapters after this chapter are scheduled for tomorrow. So we will be ending this session after a couple of minutes, after Bhupinder sir takes over and addresses any questions that all the present members have. Bhupinder sir, you can take over.
Ritvik ji, like the network management system.
Yes.
So this dashboard you had opened. So what is that IP? Which IP I have to type?
Sir, that IP is specific to my system, and even if you type it, that would this dashboards and NMS are in the next release. That will be released to you soon.
Okay, so currently we don't have any access for NMS, right?
You have access, but not all these dashboards. Current NMS is for limited resource viewing only. Not any configuration management is included in that, but we would update it to add these specific features. For
So what is the current NMS? What is the current NMS IP? So that we can see.
NMS would be 192.168, your subnet, whatever it is, your institute. Then .20, and then I think 3000 would be the port. I'll demonstrate to you later, sir. You can see it later. Let's address any other question if anyone has.
So actually, the NMS deployed at your place is currently different version, and currently soon today is under development, and soon it will be deployed across all the stores.
Yes, sir. We are having question and answers round. Please start if anyone is having any doubt or any query regarding this.
Hello.
Yes, sir.
Sir, actually, in my mobile, I am like I place the SIM inside my mobile, like 5G SIM.
Okay, private
And
SIM.
no, not private SIM. The 5G SIMs which you are provided.
Okay, sir.
Sir, in
Right.
our
Actually, I
provided
don't.
mobile or your personal mobile?
No, no, on the mobile which you provided only.
Okay, sir.
Okay.
I don't know. Like I am not finding signal in in that mobile. Like I don't know whether it is the problem with GNB, or I don't know whether my radio unit is active or not. Like
Okay,
I am not getting any signal to that mobile.
understood, sir. In that case, we have to check whether the core services are up. If those are up, then we have to check RAN services, then radio, then we will come to the UE. In that case, if it is possible for you to just switch on or power on your system currently so that we can have remote access and resolve that issue, or if it would be much better if you can provide us with your AnyDesk ID, like we can connect remotely and solve that issue in that case.
One
Because
second.
likewise, it is a very vague term to understand the issue. We have to assess system to establish what is exactly is happening.
Mr. Tarun Thakur speaking, right?
Yes, yes.
Sir, are you in the habit of restarting your servers or something?
No, sir. No.
Are your servers on all the time?
Yes, yes.
Sir,
It will be on all
there are
the time.
some
Like,
preconditions. We have to maintain certain temperature requirements for our systems, and
yeah,
the
yeah.
servers should
Yes,
be on
yes.
all the
Those
time.
things are like,
As it
those are
is.
all handled carefully only here. And if you want, I will provide my AnyDisk ID also.
Yes, yes, that would be great, sir. We can surely help in that case because please help me with the institute name as well, sir.
Sir, we are from IIT Guwahati.
IT got it. Okay, we will have a check, sir. Thank you, sir. Anyone else? We will check for Guwahati and Mesra today. And what other institutes? Just hold it.
This question was from.
IT got it. We will address them. No issues.
Any other institute have a question for the content we covered till right now? Ramesh ji, hello.
Yes, yes, sir. Yes, sir. Please.
So I am encouraging all the students to ask the question in chat box or on voice, whichever is convenient to you.
Yes, sir. Yes, sir. Please. Dear faculty member, please ask a query. If any query.
Yeah, like one observation from my side. I maybe this observation is from I think from my side only. Maybe other institute they don't may have not the similar problem. What I observed, like say after going through whole day the training, right? So like so much effort has been given from the W4S skill for explaining each and everything, but as a user, as a like end user, I thought at the end of the day, means general ideas I got, but uh, like for the system itself, I am not able to operate now. Like by seeing this training, uh, like I'm not able to run the program, run the things smoothly. I think that should be the target. Like, okay, maybe today maybe the complete theoretical aspect, but at least for tomorrow, uh, even if you are explaining us so many things, but the basic things should be checked. Like because the one institution from our side, like IIT Guwahati, also faced similar problem. Uh, those things can be checked by default. Like these are the steps we can check it, and then we can rectify from our end only. Okay, if it is not done, like if you are helping us, then like that will be really useful. Otherwise what will happen, you will solve the problem now, and then after some day it will happen again.
Okay, sir.
So
We will
that
surely
training
take
should
up
be
your
like that
point.
only, right?
And for today's call, I want to cover that up to today we have covered from chapter 1 to chapter 12, which includes basic introduction to our private 5G network lab, our basic network setup, the protocols which we have deployed on our server or UE And we have also covered sections for 5G core, 5G RAN. Apart from that, we have also covered integration of 5G core and RAN, both theory and hands-on. We have also covered sections for MEC, but we have not covered different applications or running on MEC server, which we will cover on day 2 session. Yes, sir. We have covered testing and tracing tools, which covers Wireshark and Sigma ML with hands-on training. We have also covered end-to-end network working and testing with single UE and with multiple UEs also, while we have also verified it from both G0B and core logs, and we have also traced the same end-to-end working in Wireshark parallelly. We have also covered AI/ML, IoT, costs, and security chapters. Apart from that, at last but not the least, we have covered NMS section, where we are configuring different sections for core RAN through NMS instead of command line. For tomorrow, we will be covering different peripheral devices, which includes evaluation board, router with firewall, IoT gateway, indoor CP, SIM card, drone, camera, and AR/VR. And at the last, we are covering use case demonstration of all these peripheral devices. So in the first half tomorrow, we will be covering little bit theory of each peripheral device, including its configuration and architecture and its connection with private 5G network. And at the end, in the second half, we will be covering all the use cases based on these devices, these peripherals which we have supplied in our lab. Okay, sir?
Yeah, fine. But at least initial half an hour you give such that like uh,
Yes.
the
Tomorrow,
each and every
is-
lab
yes, sir.
staff or each and every institute, like they can enable the system, and that 15 minutes or 20 minutes process they will do themselves, and then they will be able to do. So that will be recorded in your meeting also, and that will help us. And then you come to the what you are planned for.
Okay, in that case,
Yeah.
every institute can do one thing. While we are demonstrating or configuring any device or any application, they can follow the same procedure in their lab, because every lab is equipped with well furnished 5G devices and equipments. They can do the same exercise at their end also, and we can also correlate parallelly and solve problems, real time problems what they are facing actually while configuring or while running any application or while running any device. In that fashion, we can cover your point, Sanjeet sir.
Yeah, that will be fine. That will be fine.
Sanjay sir
But
told very
my point was only like initial half an hour you give for like if you have enabled the whole system, what are the few things that you have explained today also. But if you in sequence, if you will go for command line, and what are the basic steps that you need to do and check, so that network will be ensured, user equipment will be connected, then you come to the your like the rest of the use cases what you are going to show us. So that will give us a
architecture.
revision also.
We'll,
And
we'll do the quick
yeah,
revision in 15 minutes, and it
correct,
will be
correct,
purely hands-on. No
correct,
theory.
correct. Yes,
Starting
sir.
with how to power on core, how to power on GNB, how to power, synchronize RU or connect UE, right?
Very good, sir. Very good, sir. Yeah, that same things. Because I think this sort of problem I'm facing from long time, right? So that will help other institute also, and then you can come to the main target. Yeah, fine. Thank you. Thanks a lot. Change even the core or GNB. So do we need to change anything there, or the as a user applications that will be sufficient to we can means where we need to go for changes?
Let,
Means
let
our
me answer. Let me answer in two parts, sir.
okay.
This lab is provided with certain infrastructure and certain release, right? As we know, as on date, we are compliance to release 15 with this set, and we have given you only limited peripherals, right? So with these limited peripherals and the current version of release, we can do certain level of use case, right? So that very much support is available. But in case you find in your part which this lab current release is not sufficient, then we need to upgrade or rather wait for new release to come. One example could be if you are trying your organization trying some application which requires URLCC, then obviously this release or the as on date is not right release, but yes, we will be progressively move to the next release. Then your that application can be designed. Now
Yeah.
let's go to another situation which you require. Even with this release, your use case is requires some more modification. Then yes, then we have to come think of how to upgrade this lab with different sensors and maybe this. That will be a second level. Okay.
If you don't
Yes,
mind,
yes. Sir,
can you help us in?
one thing, let us take one example. So, yeah, since you had already provided one drone, right? Now, suppose we had developed only our own drone, our one setup,
Okay.
that drone. Now, that drone
Yes.
is connected with any Raspberry Pi or anything, and that services, the 5G access, we are providing with your private network to that drone itself. So can we configure? So in that case, what are the basic changes we need to do?
Okay,
You,
sir. In that case, first, I
am I
would like
able
to know. Yes,
like
yes.
yeah, okay.
I got the problem statement. Let me ask. Let me repeat the problem statement first. So, like you are having your own drone and you want to configure the drone with a private 5G network, right, sir?
Yeah, correct.
So, sir, is your drone private 5G enabled drone? Is that the model
Currently it
present
is
in?
not. Currently it is not
Okay.
enabled.
So, first step is to make it 5G enabled so that it can get communicate with it can communicate with a private 5G network. Because without private 5G connectivity, no drone can be connected with our private 5G network.
Now I'm providing access with your private network. That private
Yes,
networks where
sir.
CPE
So,
or IoT gateway, so we can provide the one access point to that drone itself, and then it is
okay.
possible on that.
Yes, in that case, if you are just accessing Wi-Fi on front all from any of the peripheral device like evaluation board, IoT, CPE, in that case you can is it means the drone is Wi-Fi enabled.
Correct.
Correct. Yes, in that case you can connect the drone.
Okay, so low then in that case MEC, the program what we will include in the MEC, that will control the drone. That is it possible to control in that way?
So just a minute, sir. So
I'm just asking general ideas here.
let me just draw this simple picture. Let's say this is a G-Node B server and this is a radio unit which is connected to G-Node B server which is radiating few signals. Okay, sir.
Okay,
This is a signal which is radiated by this is a radio unit.
fine.
RU. This is RU. This is your drone. So all the peripheral device which we have supplied like this is a IoT gateway.
Daksh,
Yes, sir.
Daksh, routing of
Yes.
packet through NATing, right, uh, will be something which you will have to look at. See, it's possible, but the packet have to be routed and to be accessible from the end to end, right, from the MEC, right? Since it's not a 5G enabled drone and all our CP devices, everything, right, they give it in another domain, they give an IP address, which the IP address is not there in the 5G domain. So packet routing and other stuff will add to an overhead which needs to be created in each of which to whichever peripheral they connect, and after ensuring the end-to-end connectivity, then maybe it can be done. You get the point, Daksh? Because the
Okay.
issue in
Yes,
this
sir.
case will be
Understood.
packet routing, okay,
Yes, sir. Understood, sir.
and also latency because the packet will be converting at multiple points.
Right, sir.
Notice.
So main
Uh,
changes we need to do at the MEC level only. That's all, not core level or
No,
G
no,
node below.
not any MEC level. See the IP address from an access point, right? It is like
Okay,
typically any access point within the home which you get, right? You get as a IP address which is given by the access point itself. It is not of the
correct,
network. So access
correct.
point normally have a NATing, and after
Okay,
NATing, so the packets which are being exchanged between your MEC, right? Whatever application you put on the MEC, and then on this end on the drone, right, those two have to be accessible to each other. The main challenge will be making it accessible, and the second challenge will be the latency, because here one level of natting is going to occur on your whatever is the endpoint where you have an access point at that point, and then and the other stuff over the 5G anyway is there, and then again at the MEC end, where you will be getting the packet, so you will have to identify from somehow with a which IP it is coming, and then take it up. So it's not a straightforward solution as such.
yeah.
I'm
We
not saying it cannot be done,
see.
but you will have to look at it multiple points and will have to tweak things to get it done.
Yeah, but thing is that like the access point we are providing through private network only. So we are not providing the access point through any other network. So access
Uh,
point from the private network only, what you had provided us, with the help
right.
of that, using this IoT gateway or CPE, because the access point is same, which you are already configured with your
See,
MEC or
uh,
yeah,
yeah, yeah, you're right. See, so for example, if we for a while we forget the private network, right? You are accustomed to using these access points at your home, at your office, right?
correct,
The
correct,
IP
correct.
which your laptop or anything you get is in a private segment, right? Now from the external world, let's go and you try to ping your IP, it's never pingable. It is never reachable. That is because of the security and the protocols which are implemented at the access point prohibit that.
Okay,
It's not a
okay,
bridging, it's a natting internally, right? So that is what, so when you want to control your drone, which is sitting on this side of an access point, and you have an MEC which is sitting on that side of a network, right? You need to have some sort of a tunneling protocol end to end between the MSC and your drone first, so that you form a tunnel which passes through the various, let's say, natting and the other stuff which I've been talking about, and so that your packet becomes end to end accessible. But doing that is technically possible, but it will add to a lot of overhead and delays.
okay, okay, okay.
Okay, hope you got my point, right?
Yeah.
And the other solution is if you get 5G enabled, drone, that could be solving this problem directly.
Yeah, means basically in
Then,
that case you are providing another device. That's all.
yeah,
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 but thing is that like you had already provided the evaluation board. What I understand that evaluation board is for that purpose only. Like if it is, we are providing services with the help of evaluation board to our drone, so it should do similar type of work. But okay, let us explore
So
further.
yeah. But the evaluation board is for that purpose only. But the evaluation board is too big a board to actually sit on the drone. That is an
Yeah,
issue
yeah,
here.
yeah.
Yeah. So the translation which comes in between, because first you're going on Wi-Fi through the evaluation and then coming up, right? All those actually create an again, as I say, it's not technically non-feasible. Everything is
Yeah.
feasible.
My question was that
But
where, how we can approach there then.
yeah, so maybe if you have something as your idea in your mind, you can always share it with Daksha and my team. We will always have a look at it, and we'll suggest you the best possible way to do it and how you can achieve your end goal.
Okay, fine. Thank you.
Yeah.
Thank you, Ajit sir. Thank you, Sanjeet sir.